Good morning, everyone. I think I'm audible and visible to all of you. Yeah. So we'll start in some time, maybe in like next 6 minutes. We are going to start with the class. Hope all of you are enjoying your Sunday, and yeah. So you already had your morning tea. I'm having mine now. So yeah, we'll start in like five, like 6 minutes. Yeah. Okay. So shall we start, everyone? So anyone who can tell me like what should be the agenda for today? So what we are going to discuss in today's class? Yeah. Anyone? Okay, so Sambit is saying fine tuning. Okay, yeah, yeah. So fine tuning is something that we are going to discuss. We'll start discussing. So it's not like we are going to complete this fine tuning today. It will take couple of session for us because fine tuning is again a very important chapter, and a kind of a chapter which you can write directly into your resume as an application. That okay, I have done this kind of fine tuning, that kind of fine tuning. So. Again, it's very important. It's just as important like a RAG concept or agent concept. So RAG concept we have already discussed a lot in a beginning, if you remember, in this batch. And then back to back, we talked about a lots of agent with respect to a different kind of a like a framework. Now it's time to talk about fine tuning because fine tuning is also a major task that we all as a generative AI engineer on any level try to perform, and which is again very much crucial for any businesses that you will be able to find out there inside a generative AI like a market. Yep. So that is the reason. So we'll try to discuss about this entire fine-tuning approach in a very practical manner. And not just that. So we'll try to even host this time not just one single model, but a multiple model. So last time we have already hosted one single model, I think with the help of VLLM, right? VLLM was again one of the library which has been used for like, ChatGPT or OpenAI compatible model hosting, you can say. Here we'll try to see that how we can try to host a different kind of a model over a GPU, over a cloud, how we can try to train those model over a GPU. So again, if you will be having a GPU in on premises or maybe over a cloud or in local, you will be able to do everything. It means technically you just need a machine. That's it. Like machine can be available anywhere on a cloud platform or maybe on premises, maybe in your local system. I will be able to use it. I will be able to host it. I will be able to like inference it with respect to the entire world. Because are super affordable. Also, 1 lakh token is not easy, sir. You are doing awesome. Thank you. So basically, you will. I think in couple of week, not couple of week, I would say maybe by next week itself, you all will be able to learn that majorly the backend part, right? Little bit, you all will be able to understand that let's suppose if I have to build a Uri kind of a system, right? So where I'm not using a proprietary model. So forget about this chat GPT and all. Let's suppose I'm using Llama series, I'm using Mistral series and some other series of model which is openly available to me, which I can download, right? Which I can download. So how we can like host it on our platform, and then how we can like give you inside a chat interface, for example Yuri. Yeah. Plus, we are trying to take one more step ahead. So, I think we all are aware about a WhatsApp number. I believe I have already shared inside your group, right? Even yesterday we were talking about it. Yeah. Basically, we are trying to make it in such a way that instead of using Yuri, people can directly interact over a WhatsApp, because that would be even more easy, right? We don't have to come here. So on WhatsApp, we all are available 24 by 7. And we are trying to make it in such a way that going forward, if someone is looking for, like interview preparation, so it will be, so let's suppose we have already prepared a lot of interview preparation series, and directly it will be able to give you. You will be even able to search a single video on a single topic going forward. So we are just working on that part. It will take maybe like a couple of more weeks for us, maybe like next whole month. But yeah, so we'll be able to achieve that part. All Indian language it already supports, so you don't have to worry about Indian languages. So it already supports all the language. Even you can like even tone, not just a language I'm talking about. Just like change your tone, right? And again, just see the response. It will be like amazing. So we have already worked on that part as well. A real application of, you can say, agent RAG and model hosting, basically like Yuri AI, the mobile application that we are trying to build. Okay, so let's. Are you mean even we will able to learn how to token are working and how to use all those things? Exactly. Yeah, this is what I was talking about, right? So then only I can say, or even you can say proudly that okay, I have built something, and then only you will be able to write something in your resume. Yeah. If I'm going to like not teach you those things, how you will be able to write it inside a resume? It won't be real, right? Okay, Sukla is saying what is the agentic approach working, helping? Why do we need a fine tuning? Okay, so the question is that if we have RAG agentic approach working and helping, so why do we need a fine tuning? So far in a class, majorly we have discussed as per the syllabus. So we talked about RAG, right? And then we talked about a agentic approach. Yeah. And then yesterday we have mixed RAG plus agentic approach both with the help of like autogen. So when we were trying to create a report generator, and I believe you all have executed that code, you all have gone through that code. Agent part is just one single like a Python file. Rest was just a helper file that we have created for scheduling, and then for sending a mail, for connecting with the Telegram. So, question is a valid question, by the way, that if we already have a RAG, and if we already have a agentic approach, right? Then why do we need a fine tuning? Any idea, guys? Yeah, any idea? So why do we need a like fine tuning? Anyone who can like try to give an answer for this? Scalar charging lot for GenAI course in lakh. Yeah, like people are charging whatever they want, and people are even paying for it. just to make it more accurate. No, not a correct answer for a purpose of a specific task. Maybe just try to explain me, as a like a layman, like think like I don't understand anything, and then maybe try to explain it to me. Direct generate a response domain specific without RAG. I mean, like, okay, that's a part, but still, if data is won't change frequently, fine tuning is good instead of maintaining vector DB. Yeah, that's a correct answer. One of the correct answer. For output inferences, no, not exactly domain specific when data is not changing frequently. Yeah, RCS is also like giving me the same answer, which is the correct one. Fine tune like customization data is changing once in a while, we can use a fine tuning. Yeah, Tabis is saying like he's correct. To reduce the hallucination, no, it never guarantees you the reduction in hallucination. So maybe like see, there is a way to control hallucination. So I mean, like not just this way. Uh, uh, According to add knowledge according to my domain, okay, context, avoid hallucination, update and retrain weight. I mean, like this is what we do as a part of fine tuning. We update and retrain the weights to get a better response as per our data rather than guessing the result. Okay, teach new skills or behavior. Okay, so let me like tell you one thing, right? So we all understands where RAG fits in, right? So RAG is a kind of a technique. So where we will try to hold our data in some vector databases in a form, in a certain form, technically in a embedding format. So we are going to hold those data. And whenever there will be a query, so this will go to a database and then it will try to match. It will try to pull n number of record, top n number of record. Maybe it will try to implement a Cohera kind of a re-ranking approach or re-ranking precisely. We can try to implement and query plus data it will try to bring and then combine it and send these data to the LLM. I believe we are pretty much clear with RAG approach, right? None of us have doubt, yeah, with respect to RAG approach. So I believe even in our sleep, we will be able to explain like very, very clearly as an RAG approach because we have done a lot of application, right? A lot of things. Okay, let me share my screen first. Maybe I can draw something and then I can talk about it. Okay. So, hmm. So basically, when we talk about RAG approach, so as we have been like talking about this since a very, very long time. So RAG is nothing but we will be having query and then I will be having a data, right? So I will be having a query and then I will be having a right data in vector DB, let's suppose we'll be having. Yeah. So whenever we are going to see a query and we'll be having a data into a vector DB. So what we will do, so basically we will try to combine this query plus data. So basically like a query will go to this one, query will go to a vector DB. It will try to fetch n number of record. Let me remove this part. So technically it will go to a vector DB and this is going to return me top n record. And what I will do with this top n record, so technically I will try to maybe do a re-ranking just to make my like record more aligned. So we'll do a re-ranking of the data. For example, Cohera re-ranking, BM25 re-ranking, something like that we can try to use. And once we will be able to do a re-ranking of this data, then what we are going to perform? So we are going to basically add a query plus a data output that we are able to receive. So technically, we will try to over here query query plus previous output. We'll try to take. Yeah. And we are going to, so we'll try to take query plus previous output. Previous output means whatever re-ranking output we are going to get. And then we are going to send this entire data to our LLM. So this is what we generally do in case of RAG operation, LLM, right? So we'll try to send this entire data to the LLM. And as per the task, so LLM is going to, or as per the system messages that we are going to give, the instruction that we are going to give, right? So in case of agents, obviously there will be a system message. Otherwise, it is going to be just a user message that we are going to send. And based on this LLM, so whatever LLM that we are trying to use, whatever series of LLM that we are trying to use, so it is going to basically refine this entire output, right? So if something needs to be added from internet, from the world, outer world, it will try to add it. If it is just supposed to do a summarization, so it will just try to do a summarization. So if I'm saying that, okay, fine, so whatever output that you are able to get, so just try to give me in this particular format, means output format, right? So this is where LLM comes into a picture. And then finally, I will be able to get the output. And I believe this is our understanding about RAG, right? Everyone? Yeah. So this understanding is correct, everyone? Yes. Now, so this is plain RAG, you can say. So whenever we, again, lot goes inside this RAG. So whenever we try to build RAG kind of a system, so metadata filtering, again, a similarity check goes into a picture, which kind of a embedding we are supposed to use, what model for a embedding, what model for a re-ranking, basically. All of these things, what databases, again, vector databases, right? So there is a complete ecosystem around RAG, you all will be able to find out. Yeah. So not just one thing, so you will be able to find out multiple things. So RAG basically. Yeah. So this is technically I can say that, okay, fine, this is the RAG that we are talking about. Okay, that's great. Now, when we talk about the agentic RAG, then what is going to change over here? So whenever we are going to talk about the agentic RAG, so over here we will be able to see a kind of an entity or agent. So agent means what? Agent means a kind of an entity which is having a LLM access, part number one, which is having certain memory, which is having a n number of tool access. Technically, it's a tool which comes into a play, right? Memory wise, so we can try to use one or two memory. That's completely fine. But when we say anything agentic simply means that it will be having a memory access, it will be having a tool access, and it will be having a like a uh, basically memory tool and LLM access. This is what we have seen. So whether we are going ahead with N8N or maybe like any other platform, and we have already used all of those platforms. So we have used AutoGen, we have used N8N, and all n number of platform we have used. So everywhere when you go and when you try to create an agent, you will be able to find out the same philosophy, right? So AI agent simply means that there will be, right, there will be a model, there will be memory, and there will be a tool. Couple of more thing you will be able to add. So here we have all of those options. So here we can try to add multiple things, right? But in general, when we say there is a agent we are talking about, so obviously we talk about majorly three things. One is a chat, basically chat LLM. One is a memory, right? One is basically a tool. I can try to add as many tool as possible. Then there is a output parser, there is a fallback, and all those things, just a additional stuff, right? But in general, agent means the kind of an entity which will be having three things. Now, altogether, what these three things does, so altogether these three things will try to make a decision. What kind of a decision? So basically, the very first part is that it will be able to understand your natural language input, right? So maybe I can talk to like this particular agent in a Hindi, in English, in Punjabi, Tamil, Telugu, depends upon the LLM capability, right? If LLM is not capable enough in terms of doing an interpretation of the language, a different language, it will not be able to do it, right? But let's take an example of this Yuri AI, by the way, for now, right? So let's suppose I'm talking to this Yuri AI for now, right? This Yuri AI, and maybe I'm trying to ask that, okay, so uh, latest कोर्स के बारे में बताओ, राइट, इन हिंदी लैंग्वेज। ठीक है, तो what it will do, so it will try to understand this entire context, and then it will, so as you can see it's typing, so it started typing, and then it has given me the output in a Hindi, right? It has given me output in a complete Hindi. Maybe I can say that give me in Tamil, right? Give me this in Tamil language. So it will try to give you in Tamil language. I can ask in Telugu, I can ask in any other languages. So technically here inside a Yuri AI, so you will be able to see that we are using a agent somewhere, right? So whenever we are going to send this kind of a messages, it will go to agent. It takes a decision, and not just one decision it is taking. It is taking a multiple decision, by the way. So what kind of a decision? So first of all, it is trying to understand your question, right? Your question, it is trying to maybe normalize the entire question, or you can say it is trying to like normalize. Okay, why it has not given me output in Tamil? Yeah, let's see. It should give me. So basically, it is trying to understand my question. Uh, Tamil, I don't know whether it is able to understand. It should be able to. No. I have asked this question in English, and because of that, it was working well. So I don't know like Tamil. So maybe tell me about latest course launch in Tamil language. Okay. So basically, whenever I'm trying to send this kind of, okay, so it has written something in Tamil in last. Yeah. Yeah, it has written again something in Tamil. Maybe I can say that, okay, just write everything in Tamil, so it will do it in Tamil. Or maybe if you are going to type in Tamil, so it will automatically respond you back in Tamil. Yeah. So like it is responding like to me in a Hindi. Yeah, for me. So Tamil, Telugu, Odia, Bengali, Spanish, French, everything it will be able to understand. Multi languages. So technically, what will happen? So whenever I give this input, it go to my agent. By the way, agent try to take a decision that, okay, an agent can have a multiple LLM access, right? So when we say LLMs, I can give a multiple LLM access to this one, maybe a fallback LLMs. Maybe I can attach 10 LLMs over there, and I can write maybe a conditions with respect to agent that use this LLM, that LLM in this situation, that situation. Depends. Context I can try to define. So basically, agent will be having a multiple LLM access, and here, so we have again the same thing. So we have like multiple LLM accesses, and it try to first of all understand that, okay, so what user is trying to understand. So maybe user is looking for some of the existing like a knowledge base output, or user is looking for something from a internet, user is looking for something from a LLM. Because in this kind of a question, when I say tell me something about a course, and I'm not saying that, okay, so basically course from which organization. So we have configured it in such a way that it will be able to understand that, okay, I'm talking about a Euron courses, right? I could have asked this question with respect to a Udemy course, with respect to a Coursera courses, right? But no, it is trying to understand that, okay, user is asking me, and user is not asking me a generic question, right? User is asking me certain specific to the organization, to a knowledge base access that I have, basically. Because I can go and I can try to ask a question that give me basically 10 for loop example in maybe Python. Yeah. Now, for this kind of a question, it will not look into the knowledge base. So whenever I'm asking this kind of a question, obviously it will not go and look into the knowledge base, as you can see, right? So it will go to the LLM and it will start generating the answer. basically. Yeah, it will, and it is, see, it's able to understand the Hindi, and it is able to understand that this user's intent is in Hindi. So maybe if you'll talk in your language, it will respond in your language. Yeah, we have not integrated a real-time search and speech so far, but yeah, very soon you will be able to find out that we will end up integrating that part as well. A lot of feature we have, like I have planned. It has started just as a fun project for me, one night, you can say, but yeah, so we are like, I have created a clear roadmap for this particular project, Yuri AI in WhatsApp, so that all of us can enjoy. So here you can see that when I say give me 10 for loop example in Python, so obviously it will not go to my knowledge base. It will not do the RAG operation. So what it will do? So it will try to do a generation from a LLM. Now, who is a decision maker over here, right? That what type of a question, what I should do. So obviously it's a agent. Now, agent is a kind of an entity which will be having a LLM access, right? So, with the help of this LLM, because LLM is very much, pretty much good in terms of understanding a natural language, whatever input I'm going to give, even if I'm going to make some sort of a mistake, it's completely okay with it, and it will be able to interpret, right? So, LLMs are powerful. Then, based on this understanding, it try to call a tools, right? Tools means nothing but a function. So function, so let's suppose function wise I have to again call a LLMs, or maybe I have to do some sort of a calculation, or maybe I have to basically go with the RAG operation. Yeah. So if agent is trying to invoke your RAG, means if agent is trying to perform these operations, means agent is like taking a query, making a decision, and then going to a vector databases, trying to fetch n number of record, doing a re-ranking, and then query plus like output it is trying to merge, and then maybe like sending again to the LLMs. This is called as what? Agentic RAG. If agent is a decision maker there, right? So RAG concept is has not changed, right? So if we are trying to drive those things with respect to agents, then we say it's a agentic RAG. Yesterday we did the same thing, right? So we were using a framework called as Autogen, Microsoft Autogen, and basically we were like holding all the data into our vector databases, and we were doing a RAG. It was trying to, like, a agent was trying to fetch the data and then like summarize it in my way, the way I was looking for, the way I have written the instruction. Now, whenever agent comes into a picture, so it makes our life lot easier, because just by writing some like a couple of line in my language, I can do a lot of tasks for which I'll have to probably write a code. But yeah, so with the help of agents, so I don't have to write the code. So what I'm trying to explain is that vanilla RAG, plain RAG, and plus agentic RAG. So both the approaches we have seen. Now coming to the next part, right? Agentic. So agentic is something that we were able to understand already. So we were able to create a lot of like a agent, and now we all understand that what is the actually meaning of agent. And one more thing, you should not call agent all the time. I have seen like unnecessary people, try to do a over engineering, and every time, whenever like in all kind of automation, they say that okay, fine, I'll try to use an agent. I mean, like, use it wherever it is required, because it will come with the overheads. It will come with some latency, right? Because it's again a process, right? It is like trying to fetch the data, trying to process those data. So obviously it requires a compute, it requires a network bandwidth. So it comes with the overhead. So it's not like it is not going to increase your latency. So wisely you have to use a agent, and obviously a memory part, right? So even in case of my Yuri AI, so it understands me now, right? That okay, so this user understands Hindi, so let's try to try to explain this user in Hindi or maybe in English, and this is where the memory play comes into a picture. Now this understands me. Now when you will start chatting with Yuri AI in your own tone, in your own language, it will start understanding you. And this is where memory comes into picture, and we have seen a lot of different kind of a memory: a summary memory, a buffer memory, or maybe like a cache, kind of a KV cache, key value pair cache memory, right? So where we try to catch, or we try to store entities, name of cities, name of person inside a memory, or windowing memory, right? Windowing memory. Generally, over here you will be able to find out this windowing memory. A simple memory is nothing but just a windowing memory, right? Where you can try to remember a couple of stuff from the last conversation. So memory wise, again, you will be able to see like same thing everywhere. Like, concept is not very different. So this is what we have learned so far, and doesn't matter which framework you are going to use, this fundamentals is going to be same and you will be able to use agentic, right? And in a similar manner, you have to go out and you have to explain whenever someone is asking about agents. Now, so this agent and this RAG approach is completely fine. So RAG approach in general we are going to use, so where my data set is changing frequently, right? Data set is changing frequently. Because in that case, obviously, it's not like feasible for me to go and train the model again and again and again, right? Because model training is a costliest approach. But let's suppose, right? But let's suppose I have a kind of a situation so where my data is not changing. For example, HR policies. Obviously, it is not going to change on a frequent basis, right? Or policy with respect to any organization, it is not going to change on a daily basis. Maybe some sort of financial like a report, or maybe a financial data, or maybe financial guidelines, regulations, it is again not going to change, right? Maybe for some sort of a marketing strategy, so maybe I'm not going to change my marketing strategy, or maybe my sales pitch, yeah, my product has not changed, so I'll not try to change my sales pitch for a customer. So in every domain you will be able to find out a certain entities or certain data which is not changing frequently. Maybe in that situation, so I can try to adopt a fine tuning approach. Yeah, maybe I can go ahead and I can try to use agentic inside a fine tuning. That's okay, because agentic is something which is a decision maker unit, right? Not a output generator unit. I mean, like, based on the decision, so obviously some other entities are going to generate the output. But yeah, this is where agentic comes into a picture. So person who have asked me a question that when we have RAG and agentic, so you should not first of all compare with agentic and this fine tuning, maybe RAG versus fine tuning. Yeah, you should do the comparison. So RAG means wherever data is changing frequently, I'll just go ahead with the RAG approach. Wherever, again, not all the time, because I will check the cost, right? So what is the cost for me to, build one final model? That's first thing that we all should check. The second thing that we all should check over here, the overheads, because again and again you have to go for the retraining, maybe in every month, every 2 month, 3 month. In that case, I will not prefer to go ahead with the fine tuning. And again, what kind of a fine tuning we are doing, that also matters a lot, because not there is not just one single kind of a fine tuning you will be able to find out, which I'm going to teach you now. Yeah, so this is the overall understanding that we have so far. Yes, everyone. Yeah. What if for a weather forecast? For weather forecast, why do you need even a fine tuning? Why do you need even like a, this like a fine tuning? So nothing is required. So basically, whatever data that you have, so just try to create a build up or create a forecasting model. It will be a very lightweighted model for you, and then do the prediction. This is what we do. So it's not like we have a agentic and we have a RAG capability. So everywhere I will end up using. Case by case, you are supposed to take a decision. Yeah. Many places, not many places, in majority of places I have seen that people don't understand the fundamentals and they end up doing a over engineering and then they regret it, right? And it happens in all the organizations. So it's like kind of a universal truth. Even in your organization you will see the similar kind of a things. Yeah. Parser and fallbacks are not visible in my this one. So basically double click and then switch it on, this one. So I have just like enabled it. Maybe I'll just go and disable it. So now it's not even visible here. Yeah. In agent. Now, so basically, in layman language, fine tuning means a query optimization. No, not at all. It's an incorrect statement. So fine tuning means, so let's suppose I have a model, right? A fine tuning means, let's suppose if I have a model. So basically, I'm trying to give an additional knowledge. For example, if I'll talk about a chat GPT model, right? For example, chat GPT model will not be able to understand about Euron, because a chat gpt is been trained on a generic data. Yeah, generic data. Now chat gpt has already opened up some of their model, so oss 20b, oss 120b. What I will do, so I'll try to take that data, I'll try to take that model, I'll try to fine tune it with all the Euron data. Then if I'll go and ask a question, it will be able to give me a more accurate result with respect to Euron. So basically, if I have a sales, like I said, if I have a sales data, if I have a marketing data, which is my proprietary data, which belongs to my company, it's my company's HR policies, it's my company's financial policies or financial data, right? And if I have to, if someone has asked me to build a model, right, which can give an answer based out of my data set, then I will say I have to go ahead with the fine tuning. So fine tuning simply means that training a model, as simple as that, training a model but with my data, that's it. We are not going to train it from the scratch, right? So we are going to basically train some of the best LLM model which already understands English or maybe some other languages, or which is already like designed for some of the tasks and trained for some of the tasks, basically. So it's called as fine tuning, as simple as that. Okay, I hope this is like making sense to all of us. Yeah, the meaning of fine tuning. So I'll show you. So as we'll progress, I think our understanding will be even more clearer, right? So RAG, this is just a summary I was trying to give you, by the way, that what is RAG, what is agentic, and then why we are supposed to use, which one we are supposed to use. Fine tuning is like optimization for a result. I mean, like not an optimization. It's like kind of a line from an internet, you can say, but it's more like training with my data. That's it, right? Optimization for a result will be having a vague meaning. For example, when you say optimization, right? Let's suppose my model is having 400 billion parameter. Let's suppose 120 billion parameter. I have done fine tuning, right? And then I'm trying to run it on a some low hardware. It is not optimized. So optimization is having a vague meaning itself. Optimization in terms of what? In terms of hardware you're talking about? Maybe I have done fine tuning, but I have done maybe full fine tuning. So optimization in terms of maybe a training approach, optimization in terms of giving you output, optimization in terms of what? So that's the reason I never take this like word called as optimization with respect to fine tuning. Simply making model better for desired output, making model better for your data, basically. Yeah, your specific data, your proprietary data, by the way. Okay, let's try to understand couple of things. I think pretty much like things will be clear. So let me open up my VS Code. I'll just follow along with theory and practical both parallelly. I have prepared already a beautiful example for all of you, by the way. Yeah. Don't worry, I'll go with the explanation. First of all, I'll just go with the overall understanding. So here what I have done, so actually I have prepared not just one data for domain. So basically I have prepared a multiple domain data, finance data, healthcare data, HR data, marketing data, and sales data. So that I will end up covering not just one kind of a fine tuning, but a multiple kind of a fine tuning, and that too a different kind of a data set. Yeah, different kind of a data set. So and again, so here when we talk about a fine tuning, so your data set should be like prepared in a different way, and that depends upon the kind of a fine tuning that you are going to do, by the way. Yeah, and yeah, it took almost 1.5 hours of time for me to generate these models. So I have trained this model in my local system. I have even created an API for that and Docker deployment for that for GPU H100. But everything I'm not going to discuss today. So step by step I'll go. Right. Theory and practical both in parallel. So lot of like understanding we have to like take from here. So here I have prepared the data. So whenever we talk about a fine tuning, so we have to take a decision in a very first place that what kind of a fine tuning we are supposed to go ahead with. Now the question arises, right? And then obviously with respect to that kind of a fine tuning, I have to prepare a data. For example, so if I'm going with the DPO kind of a fine tuning, RLHF kind of fine tuning, my data set format is not going to be same as maybe like some other data set. See, so here I have some different kind of a format of the data, instruction input, right? And here I have a different kind of a prompt input chosen rejected, prompt input chosen rejected, right? So different kind of a data. And this is basically a India centric data, by the way. Yeah, it's a India centric data I have prepared. It's a good amount of the data. And even when you are going to do a fine tuning with respect to your own company data, Depends upon the fine tuning approach you are going to choose. You have to prepare a data first. This is where this data creator, or you can say data labeler people, comes into a picture, or domain expert people comes into a picture, or functional people comes into a picture. So what they do, they prepare a data, right? Even in all the companies who try to train the model, you will be able to find out a big team, so where they just try to prepare the data, because unless and until your data is not prepared, you can't go ahead with, like doing a model training. Training means again fine tuning, right? So you won't be able to do that, and it's a big task. Obviously you must be having a functional expertise. Someone is supposed to validate all of this data, that if this is the input, then this is the valid output. Because if someone is going to make a mistake with respect to this data labeling or data arrangement, your entire model will go for a toss. As simple as that, right? Your entire model will go for the toss. EDA, no, it's not called as EDA. EDA is like different. Exploratory data analysis, like that is just like generating some sort of a stats out of the data. This is basically a actual data preparation for like a model training. Yeah. So it's not EDA, by the way. EDA, simple, go after the word, exploratory data analysis. So EDA has been used for the analysis purpose, just to understand some stats, some meaning, some formatting, and some trend inside the data. That is technically called as EDA, which we keep on doing since our childhood. Yeah. So we all do that EDA part since our childhood, right? We all have done some like EDA with some like a house price prediction or something. Yeah. So yeah, basically, yeah, this is called as data annotation. So data preparation or data annotation. So we are trying to annotate a data. So data annotation happens even in computer vision and in NLP. So again, data annotation we try to do. So where we need some sort of a domain expertise. So a person who understands this data, a person who understands your domain, and who have a proper instruction that whenever person is going to prepare the data, always try to prepare in that particular way. ETL, no, again, it's not a ETL. Extract, transform, load. Yeah, it's a part of ETL. It's one of the part of ETL you will be able to find out. Fine. What is the minimum size of data required to increase the model accuracy for a specific domain? I mean, like at minimum, whenever you are trying to provide the data, so always make sure that it must be like more than 500 unit, or maybe 1000, right? I think that's a good number, so that your model will be able to at least adjust itself. Yeah. So why JSON we can train LLM on a text data? I mean, like it's a format, right? It's a format which has been defined. So if someone has defined that, okay, for this model, you can take a data in a text format, take a data into a text format. It's just like saying that why your name is Yogendra Pratap Singh, because your parents has defined that name, right? And because of that, so we all are able to call you as a Yogendra Pratap Singh. Yeah. In the similar manner. So whoever has defined whatever kind of a data and whatever kind of a pattern, this is pattern, right? I just have to use it. I don't have any other option. Yeah. So step by step, we'll try to understand, right? Step by step, we'll try to like understand each and everything. So here, as you can see, so first we have to choose what kind of a fine tuning we are trying to do. Part number one. Part number two depends upon that fine tuning. I have to pick, or I have to prepare the data set, right? That's again a heavy task. It's not an easy task where like you need a big team, and again, like as your data will grow, so obviously your team size, and maybe either increase the team or maybe increase the time, right? And then you have to choose basically a hardware, right? That okay, fine, so this is a hardware on which I'm going to do a training. Then we try to evaluate those model, we try to test those model, which is a small part, and then we try to host those model somewhere. So this is a cycle that we try to follow in general, right? So first what we do, so first of all we try to uh, select or type of fine tuning. So this is something that we try to select, and there are like so many different kind of a fine tuning approach you will be able to find out. Now based on this approach, if this approach is already defined, I have already selected that what kind of a fine tuning I'm doing, then what I will do, so I'll try to go ahead with the data preparation. Yeah. So this will be my step number two. Once data will be prepared, then I will do a math, I will do a calculation for what? So for a hardware, by the way. Hardware. Hardware means a GPU, CPU, wherever I'm going to train it, because again, that plays a crucial role, right? So I'll try to pick and choose the hardware. So data preparation is done. I'll try to pick and choose the hardware, right? Code part wise, it's not going to be difficult. So prepare code and infra, right? So code part wise, it's not at all difficult. You just have to, adjust couple of parameter. It's very, very easy code to understand, believe me. And all the parameter you all will be able to train and tune. So basically type of fine tuning I have selected. After that data I have to prepare. So depends upon the fine tuning. Then I have to select the hardware. Depends upon the data and the model, the base model. Yeah. Because hardware depends upon both which model I'm trying to train, right? And what kind of a fine tuning I'm trying to do, and then what volume of data. So based on all three factors, my hardware, like I have to choose, right? It's not like just on one single factor I will be able to choose my hardware. And then like code wise, like it's like a very basic one. Code and infra setup I'll try to do means migrate all those code to that particular platform where I'm doing a training and data and all those things, right? And then once my model will be ready, then I will have to evaluate my model, or you can say test my model. And again, so that is like again contextual, what kind of a model, for what purposes I'm trying to create the model. Even so, based on that I will try to perform the testing. And once this testing is done, so then what we do, so then we try to send a model to a production. So basically send the model means inference or host a model in a production. So again, I have to go ahead with the infra calculation, and then kind of a input that I will be receiving, or you can say a kind of a hit, right, which will come on my model per second, per minute, per hour, per day basis. So I'll do the math over there, and based on that I'll calculate the infrastructure. What is the kind of a latency which I'm expecting? So let's suppose I am trying to create maybe URI kind of a system. So obviously over here latency should not be more than maybe like a 5 second, right? 5 to 6 second. So obviously I have to host kind of that kind of a model on like that kind of a infra where it will be able to scale, or it will be able to give a response with that latency. Sometime, for example, the yesterday's example that I have discussed. So over there, we need a model once in a whole day at 9 o'clock, right? This is the schedule. This is something that we have written in our scheduler. At 9 o'clock, it is supposed to run itself and generate the report. So over there, I don't need a real time model. So even with a very low infra, I will be able to host that model for that particular use cases. So I will be able to use it. So everywhere I don't need a heavy infra. It's case by case basis, right? And this is a decision that we always try to take. So it will go to the production. So in general, this is a kind of a flow that we try to follow whenever we talk about basically this fine tuning, and lot goes inside every step. So many things goes inside every step on a case by case basis, right? And where we try to take a decision. So in general, this is something that we try to follow. Making sense, everyone, guys? Yeah. So first, coming to a type of fine tuning. Now let's start breaking it down into multiple steps. What is the difference between prod and hardware module? So see, here I have written a hardware for a training purpose, right? And here I have written a production. So once your model will be tested, you will send your model for a real inferencing. So this is a hardware which is required only one time, right? This is a hardware which is required daily basis, or as per your application, right? So if your application is running 24/7, once in a year, once in a week, once in a day, so this one. So production hardware will be different, and then this hardware will be different. Somewhere we need like heavy hardware over here. So while doing a training, so one hardware is part of like a, training. One is a final inferencing. So when my model will be like a trained, and then it will serve the user, the end user. Okay, fine, everyone. Yeah. So now we have to understand that what is the type of the fine tuning. Generally, we will be able to find out. So any idea, guys? What is the type of fine tuning? Any? I think I have discussed so many times, even in your interview preparation series. So we had a lot of discussion on this one. A type of fine tuning. Okay, Naresh is saying like a supervised. Okay, okay, unsupervised. Okay, yeah, that's okay. Supervised, unsupervised. DPO. What is the full form of DPO, by the way? RLHF. Okay, Q Laura. Fine. Anyone who can give me like full form of DPO? Yeah. DPO means direct preference optimization. Parameter perfect. Yeah. Message not showing to me. Okay, I think people are pinging to host and panelist. There are two options, right? So there is an option to ping to everyone. You can just select, and there is an option to uh, so host and panelist means only I can see the message. You have both the options, by the way. Yeah, guys, I think you are able to see all the options. Maybe you can select everyone when you are messaging, right? So two in a two section, just select everyone so that everyone will be able to see your messages. All of us can see your discussion. Otherwise, only I will be able to see your discussions, which many people have like pinged. Yeah. So Tabis is saying LoRa, QLoRa, DPO, RLHF. Yeah, that's okay. Selective, adaptive based LoRa, prefix tuning also. Yeah. So there are like a lot of different kind of a fine tuning, not just one single type of fine tuning. You will be able to find out in this entire world. Lot of different kind of a fine tuning. But overall, right, overall, if I have to like, define and make this fine tuning like things pretty much easy for all of us. So I can like, I can say that maybe, right. So maybe I can categorize a fine tuning in like a couple of cases. So one is full fine tuning, right? Now, what is the meaning of full fine tuning? So, whatever model that we have, whatever model, because model is nothing but a transformer, right? This is what our understanding is. So, transformer. So, whatever transformer architecture that we are going to consider, we are going to change the entire weight. Means we are going to update the entire weight as per my data. Now, this is one. This is something called as like a full fine tuning. This is one of the part, right? So one is like a basically full fine tuning approach. One. Now there could be a second one, basically. So second one can be like a prefed, basically PFET. So parameter efficient fine tuning, right? Parameter efficient fine tuning, PFET. So PFET again another like a kind of a fine tuning that we try to do. So where we don't try to change the entire weight of the model. What we do instead of like a changing the entire weight of the model, so we try to update just some of the weight. For example, in a layman way, again, if I have to explain it to you, so let's suppose this is my model, right? This is my actual model, and we have a transformer architecture over here. This is my actual model. So in case of parameter efficient fine tuning, what I will do, so instead of changing the entire weight of the model, I will try to maybe add some parallel network. Yeah, I will try to add some parallel network in this way. Maybe I will try to add some network over here. Yeah, and instead of changing the original weight of the model, I will change what? I will change this one. I will change maybe this one. Depends what kind of a fine tuning I'm trying to do. And next time, right? So that this big model is having a generic understanding. Yeah, this big model is having a generic understanding, and this is small network, a neural network, right? This small neural network is having a understanding about my data. Yeah. Now, whenever some input will come, right? So whenever someone is going to do or call the inferencing, right? So whenever some input will come, technically what it will do, so whenever some input will come, so it will try to give the output based on the input inside my big model, which is like having an understanding about the data, plus the model which I have trained, and it is basically going to give me the output, right, from both. It is going to combine the output, and then it is going to give me the final output from both the parallel one and the big one. The big one which understands, which is having a universal understanding of the data, right? And the parallel one which is having a specific understanding about my data set. So this kind of a training, so where we try to add a parallel or maybe this vertical kind of a layer or maybe just one single layer at the end we try to add, this kind of a fine tuning is called as PFIT, parameter efficient fine tuning, right? So where we don't change the weight of original model, instead of doing that, so we try to change a weight of basically uh, parallel weights, right? We try to add a parallel neural network. So this is how you should understand a PFET, PEFT, parameter efficient fine tuning. Now, when we talk about a parameter efficient fine tuning, so inside that you will be able to find out, inside this parameter efficient fine tuning, you will be able to find out in general uh, two different kind of a fine tuning approach. One is a LoRa, one is a Cora, Q LoRa basically, right? Now, what is this LoRa, by the way? So it's technically a part of basically this PFET. PFET is a concept, right? It's a concept, the concept which I was trying to explain it to you. So parameter efficient fine tuning. It's a concept, and inside that, LoRa and QLoRa comes into a picture. So let me write it down over here. Uh, PFET, and inside that, so basically LoRa. So this is something that you will be able to find out. Now, what is the full form of this one? So it's nothing but low rank adaptation, right? Low rank adaptation. So here, this is the example I was talking about, that there is a model, a big one, right? And parallel to that, so I'll try to add a fresh neural network. I'll try to train this entire entity, but not the big model. I'll try to train only this one. But, and when it will try to give an output, so it will try to give an output by using both of this entity. So this entity which understands the universal data and this entity which understands my data. So in this way, I'm like trying to avoid a billions of parameter training. So maybe I'm trying to add, or I'm just trying to train a fraction of the parameter, right? So in this manner, my training will be, pretty much efficient. I can like train it in a low hardware, right? And I will be able to quickly train it, and quickly I will be able to use it, because I'm not supposed to like, I'm not changing the whole weight of the model. So this is where called as low rank adaptation. Let me write it down. So this LoRa is nothing but, it's called as low rank adaptation. In some of the classes I have even like explained its mathematics behind it. So there is like a small calculation, rank calculation, which goes behind. Maybe I'll try to discuss even in this class once again. But yeah, in some of the classes, I think in the previous generative AI classes, I have already discussed about like how mathematics wise this ranking works, right? Mm. Then there is something called as Q LoRa, right? Again, extension of the same thing. You will be able to find out. So there is something called as Q LoRa. So now what is this by the way? So, and how it is different from the above one? So it is nothing but it's a quantized one. So whenever you will be able to, let me write it down. QUANTIZED, quantized one. So Q LoRa. So quantized LoRa, simple. Quantized low rank adaptation. Yeah. So whenever we say quantized, so quantize simply means that we are trying to change the scale, right? Scale of what? Scale of the weight, by the way. So in general, let's suppose I'm trying to represent a integer by using a 32-bit. Yeah, by using a 32-bit means 32-bit of a space is required to represent one single integer. And again, so if I'll talk about your CPU or GPU, a silicon chip where like actually computation happens, so it's understands a bits, right? It understands bits 0 1 0 1 0 1 0 1. So for to represent one single integer, let's suppose if I'm taking 32-bit of a space, yeah, 32-bit of a space, and now when I'm trying to like do a computation, so obviously 32-bit is trying to do a computation with a 32-bit, that is space, that length of the bits is will like get into the computation. And obviously, if I'm talking about a billions of parameter, so as my parameter will increase, so my compute will be heavy. My compute will become heavier and heavier and heavier. So what people said that okay, let's do one thing. So maybe try to represent that 32-bit into maybe like a lower bit, 4-bit, 8-bit, 16-bit. How we can do that? So just we are trying to optimize the space required of, or maybe we are trying to reduce the bits. So if we are reducing our bits So yeah, we are losing some meaning of the data, some fraction of the data we are losing over there. But overall, let's suppose I'm trying to write 2.10, right? Let's understand in this way. So let's suppose there is a number 2.10. I will try to chop off 10, right? Still, I will be having two, a base value two. So I will be able to like think that okay, think in this way that okay, I'm able to chop off this value. But yeah, so if by chopping off these values, if I'm able to retain majority of the information, means that two, which is a base, which is like a major one, if I'm able to retain it, then obviously I'm not losing much of information, but I'm trying to make my calculation pretty much faster. And that was the approach you will be able to find out in terms of quantization. So instead of representing any numbers on a higher bit, higher scale, reduce it. Maybe from 32, bring it to 4 bit, bring it to 8 bit, bring it to 16 bit. So your computation will be reduced, and we are talking about a billions of parameter. And technically, when we say my model size is 500 GB, because that's that kind of a model you will be able to find out, or maybe a 50 GB, all those sizes are coming from your weight size. As your weight, number of weights will increase, and like this bits will be increased, obviously bits will eventually converts into your sizes, MB, KB, GB, whatever you can say, right? Because eventually that's a space it is going to take. So that was the whole idea, that was the whole approach in terms of doing a quantization, that try to represent a number into a lower bits and then do a computation. So computation will be lighter, and size will be like and again reduced in that proportions, and I will be able to host that model on any hardware, right? Even on a mobile devices I will be able to hold like a model, uh, or any other devices, right? So even on mobile or TPUs, tensor processing unit, which is again you can say brother sister of like a GPU, right? But for a lightweight small devices, basically a tensor processing unit. So there is something called a CPU, GPU, and then TPUs. So it will be able to even run on a very very light weighted devices. And yeah, I will be able to make use of these LLMs on remote or mobile devices or edge devices as well. Technically it's called as edge devices. So this is the approach which has been adopted. It's not a new approach, I would say. It's a very very old approach. Even in computer vision we does this kind of a things a lot. And I think in my experience, I think I'm doing it like since like 6 7 years, right? So we are trying to create a quantization model in terms of computer vision, and same thing they have adopted even in case of a NLP, because we all know that size of LLMs is increasing day by day, day by day, day by day. So yeah, we are trying to do a little bit of compromise with respect to the output, but in terms of speed it's like a thousandth x of speed, and in terms of storing those things inside our memory, so we are like trying, we are able to make a lot of improvement. So this is again, so this QLoRa is nothing but just an extension of your prefet. And here for this model, the big model that we have, right? The big model will be having most of the weights. So for a big model, we are trying to basically represent all the weights into its lower bit. So maybe previously it was into a 32 bit. Now I'll try to represent it into a 4 bit or maybe into a 8 bit. That is something happens with respect to QLoRa. Then after QLoRa, right? So you will be able to find out in general a kind of reinforcement learning based approach, where you like go and try to like train the model with the help of basically human input, right? So with the help of human input. So again, RLHF, I can say, reinforcement learning based approach. So where you train the model, you give a feedback, then again it will try to consider the feedback. Now based on the consideration of the feedback, so it is going to again train or maybe detrain, yeah, retrain the entire model. So again, inside that, you will be able to see a PPOs or DPOs, direct preference optimization kind of a technique comes into a picture in general, I would say, right? In general. Again, there are multiple ways by which I will be able to categorize. But yeah, so we are going to learn about a full fine tuning. We will be learning about LoRa basically. We will be learning about a QLoRa, and we will be learning about practically, right? We'll be learning about even a DPO, uh, which is not exactly the RLHF but kind of an extension of a RLHF itself. So let me write it down. 3. Why it's changing? DPO, direct preference optimization. Yeah. Now, so when we talk about these approaches, by the way, so obviously based on this approach, we have to prepare our data set, right? Domain is not necessary over here. I can train these things with respect to any kind of a domain, with respect to any kind of a data, right? So here, I can even train for the coding, I can train for the mathematics, I can train for maybe a generic text, whatever I want, I can train it. Everything will be under my control. Now, when we talk about a full fine tuning, right? When we talk about a full fine tuning, so basically it's a supervised approach of doing a training, right? Full fine tuning means it's a supervised approach of doing a training. So here, what we try to do, so whenever we try to prepare a data, right? Whenever we try to prepare data for a full fine tuning, so my data should be available into a input and output pair, by the way. Yeah, input and output pair. So for example, if I'm trying to train my GPT model, OSS 20 billion parameter, OSS maybe 120 billion parameter, or maybe any Llama series, any Mistral series, any DeepSeek series, if I'm trying to train, right? So obviously I should prepare a data in a input output pair, right? That okay, fine, so this is the prompt and then this will be the output, or this is going to be the completion. Eventually this is what we have done over here. So if you will look into this healthcare data set, right? So healthcare data set, so we have prepared this data. What are the symptoms for of a dengue fever common in India during a monsoon, right? So we have like this kind of instruction, then we have input as a blank, and then we have a output pair, right? So output is a very very long output that we have prepared over here. So this format is required. So you must be having some sort of a instruction, and then you must be having some sort of a output. Again, if you will check my HR data set, so instruction, input, outputs, in a similar format, we have prepared all of these data sets, right? All of these data set. So whenever we are talking about a full fine tuning, you should always prepare a data in this particular format. This key can be like different. You can give a different name, because at the end of the day, we are just going to do a mapping, right? So this name can be different. Instruction, input, output. Like for example, if I have given, you can give some different name. That's okay, because it's just a key mapping by which we try to say that okay, fine, this is the input and this is the output for you. As simple as that. Yeah, as simple as that. So in this format, everywhere, every time, everywhere, you have to prepare the data. Making sense? In case of like a full fine tuning, guys. Yeah. Yep. So does full fine tuning means as a training the whole original model again we lose the original model parameter value? Yeah, this is the meaning of that we are changing the entire weight. No, we will not lose the entire meaning of the original model, because see, it is going to adjust the weights, like we have certain numbers means weights, and it is going to adjust the weights based on what? Based on the losses, right? If you understand and if you remember the training concept. Yeah. So basically you have given some combinations of a text, of a embeddings, and obviously my model is good enough to understand those things. So basically it will not try to adjust much, it will try to just adjust with respect to my given data itself. It is not going to like adjust to some uh, big you can say a numbers. Yeah. Okay, now here, so we have a instruction, we have a input, and we have a output. What is the meaning of this three things, by the way, right? So when I say this instruction, right, so it simply means that what I want my model to do. This is what I'm trying to say over here. This is the meaning of a instruction in terms of preparing a data. When I say input, and mostly my inputs are blank, so it's nothing. It's again optional, always optional. So instruction, I can try to give, I can like avoid it. That's completely okay. If I'm giving it again, well and good, it will be having more capabilities, but yeah, I can keep it blank. And in my cases, I have kept it blank as of now. So instruction means what I want my model to do. Input means, so basically a external context if I wanted to give to the model to complete a particular task. Task means the instruction. Yeah. So how does a paternity leave and childcare policy works? So simple instruction, and then I have given the output. I have not given any kind of a internal or external context. So maybe I can fetch some data from the internet, some different companies' HR policies I can try to fetch, and maybe I can try to give as a reference, as a context. But again, it's an optional one. Yeah, it's an optional one. Maybe I can try to attach a policies. Maybe I can try to fetch some data from some table and then try to attach it. But like I said, so hope all of you are able to understand this three parameter. Instruction means the input, the command that I'm giving to the model. Input, it's a context. If I wanted to give a context, I will give. If I don't want to give a context, I will not give. For example, you must have seen that you try to give a user input, right? So you try to give a context that you are a professor, you are a coder, you are a senior architect, kind of a instruction, right? Or maybe some sort of a context we try to give that, okay, behave like this, so that it will be able to, change its behavior. So this kind of a data you have to prepare for your any kind of a fine tuning you are trying to do. So technically a full fine tuning I'm talking about. So where I will change the weight, entire weight. I'll try to train the entire weights. But again, so it will not change the weights drastically. The reason is very simple. My model is already trained, so losses will not be much. It already understands your like a combination of your English, right? Combination of your all of these words. It's the best one. So is it like a memory? Not like a memory. Memory, we talk about it in a different context. It's like more like a giving some sort of a additional information, context, right? So basically like something like that. Yeah. So for example, if like you are going to ask a question that who is Sudhanshu Kumar, and then you have written something, but you have also given my childhood context to this one, just like that. Yeah, think in that way. So input instruction is basically like what you want your model to do. Input means just a additional context which is optional, not mandatory. So you can give it, you can leave it, up to you. Output and instruction is important. So this is the input. Technically you can say that this is the instruction I'm giving to the model, and this is something that it is supposed to reply to me, right? So as you can see, how does paternity leave and child care policy work? So male employee gets 7 days paid paternity leave within 6 months of childbirth as per my company policy, right? As per my company policy. Additional 5 days can be taken using a CL and EL, for adoptive father, 5 days leave granted. New parents both can avail a flexible working hour for 1 year post childbirth. Daycare allow for rupees 5,000 per month provided for a children below 3 year. Crèche facilities available at the corporate office for the parents' convenience, right? Now, just see the detailed answer. This is where you need a human, right? Human. If you are not going to prepare a data properly, entire training will go for a toss. As simple as that, right? So it takes a lot of time, lot of observation, lot of like a back and forth checks is required. Then only you will be able to prepare the data at the end of the day, right? So data preparation is a tough task, obviously, right? It is a tough task. So you should be very, very careful. And we spend a lot of time, lot of like a verification we try to do in a multiple manner. Most of those like things are manual, by the way. Yeah. And there must be some observer, there must be some subject matter expert or functional people. So who will be doing all of these things, plus some HR, obviously. If I'm like talking about HR data, so obviously HR understand these policies, right? So obviously they have to verify, they have to approve. If I'm talking about the finance, so some finance guy must be involved. Healthcare means some healthcare guy must be involved who understands this data. Marketing, sales, it goes for the same. Okay. So when I talk about a fine tuning, right, full fine tuning simply means that I'm changing the entire weight of the model. But yeah, weight will be changed versus the loss, and system already understands the combinations, right? Text combinations and grammar and everything. So it will not adopt, like it will not like change the weights drastically. It will just do the minute changes. Now, so if I'll talk about a data set for this parameter efficient fine tuning, right? So again, it's going to be a similar kind of a data. Yeah, similar kind of a data. It's not going to be different kind of a data that we prepare for a prefed. Here, so what we are changing, so we are not talking about the data. Data can be anything, right? So here we are talking about the architecture of the model. So in case of LoRa, so we are trying to add maybe this parallel layer of a neural network, and this network we are trying to train with the original data, and this network is going to be as it is, right? This is what we do with respect to LoRa. QLoRa, so we are trying to, change the bit representation of this big model itself so that my model will be very, very small. And then we are training the model parallelly. So basically it's a quantized LoRa, right? So the extension of the LoRa. So here in this approach, again, your data set is going to be same. You are not supposed to change the data. So here you will be able to find out that this is what I have been doing. So when I was like trying to prepare the data, you will be able to see the same thing, instruction, input, and the output part. Yeah, instruction, input, output part. So it's the same data, similar kind of a data format. Instruction means command to the system, and then input context. I have not given that. I have just kept it as a blank, and then output means what will be the output with respect to that. So we have a marketing data, and if you read out this data, it's a real. You will feel like it's a real one. It's all the data set is making sense. This is how I have prepared my data set. By the way, same goes with the sales data set. Same goes with the HR data set. Same goes with the healthcare data set, instruction, input, output, right? Because I'm going to use all of this data in either LoRa, either Cora, either full fine tuning, or maybe simple prefet, right? Just to call a prefet. So these data set. Now here, in case of DPO, you will be able to see a little bit of differences, right? It's not same, by the way. So here you will be able to see something called as prompt, input, chosen, and rejected. So all of these like a little bit of differences, right? Not much of differences, but yeah, a little bit of differences. Basically, you will be able to find out. So here, what is a DPO, by the way? So full form wise, DPO is nothing but it's a direct preference optimization. Fine, direct preference optimization. Now, so here, basically we try to give here a pair of a preferred versus a rejected one. It's kind of a reinforcement learning, right? So we are trying reinforcement learning means give a feedback, and from the feedback it will learn. Now in the DPO, direct preference optimization, what we try to do, so we try to give a preferred one and versus a rejected one, and based on that, so it will be able to understand that okay fine, so what I'm supposed to understand, like what I'm supposed to basically give as an answer against this one. So here, as you can see, this is a prompt means instruction, right? That okay fine, do this. Everywhere you will be able to find out the prompt. So prompt means basically, for example, how I can save income tax legally in India. Fine. Now this is the instruction, and for this instruction, model is supposed to learn. Fine. So I'm talking about the finance document. Let's suppose finance policy. Now input means again same thing, context we are talking about. So we have already discussed. So if I would like to give additional references from internet or maybe from my databases, I can do that. I can leave it optional. Then for this input, this is the chosen answer. Means this is the correct answer. So legal tax saving option includes section 86 rupees 1.5 lakh PPF, ELSSS, insurance, tuition fees section, and all these things. This is the option which is given to you, which is technically a correct answer, chosen one, right? Against this answer, so just invest in a mutual fund and you can save all your taxes. You don't need to worry about any document. Now this is something which I'm writing against it, means a rejected one, that okay, you should not learn this one. So even by not learning something, you are learning something, right? Yeah. So let's suppose if I'm like teaching my child that do not learn the abusive word, right? So basically, even by asking him or her not to learn the abusive word, I'm trying to teach, and basically my child is learning. Yeah. So not learning something is also a learning process, basically, right? It's a learning process. So this is what we do, and basically you can try to treat it as a feedback loop. Yeah, feedback loop. So basically, this is my instruction, and this is my context. So context is blank, let's suppose, and this should be the ideal answer. And this is something which I just want my model to unlearn, or you can like say that okay, fine. So whenever like not give this kind of answer for this kind of a question, not to give this kind of answer. This is what is called as rejected. So chosen one and the rejected one. So this is kind of a feedback loop, the way we try to like behave in a RLHF, right? Reinforcement, like learning with the human inferences or human interference. So similar kind of a data we are trying to prepare over there, so that it will learn from the preferences, yeah, and again from the rejected as well, both. So this is data. So you will be able to find out, like for a RLHF, for a DPOs, we are having a different kind of a data, but for like full fine tuning and like a LoRa, Cora, all those things, we have a similar kind of a data. So I believe we all understands a data preparation strategy, right, guys? And you can read out all this data, every data, the data that I have prepared. It's not a vague one. It will, every line will make you like give you a sense. And I'll show you my output also. Yesterday it took almost like 1.5 hours of time for me to train this five model, right? So train this five, one, two, three, four, yeah, 5 or 6 model, I can say. And I'll show you the final output. It's amazing with respect to this data set. It's literally amazing, right? Means you can directly send those model to a production. So basically, I have not trained for a lot of epochs, just for 2, 3 epoch I have trained my model, right? And that too in my local system. It's giving me pretty much good result. Yeah. We'll learn those things. But yeah, I hope data preparation strategy is clear to all of us. Yes. Okay. So now we all understands that, okay, so if I have to go ahead with the full fine tuning, LoRa, Cora, so what kind of a data I have to prepare? If I have to go with the DPO, so what kind of a data I have to prepare? And we understands a meaning of these like, things as well. So everywhere, wherever you will go in this world, you will find the exact same thing, right? It's a universal one, by the way. There are like millions of model out there on Hugging Face. Even you can log in into your this OpenAI interface, and even inside that you will be able to find out like models, and inside that you will be able to find out a fine tuning panel where you can go, you can try to put your data, and then you will be able to do a fine tuning. This is how you should prepare that. This is how you will end up preparing the data. So basically, it's a kind of approach which is applied to all millions of model out there in real time. Doesn't matter you are doing it in a class or tomorrow you will do it in your company. Nothing is going to change. Yeah, not even a bit of it. Also just wanted a glimpse how you have prepared. See, it's a kind of a manual approach, right? It's a kind of a manual approach. You need like some document, you have to parse through some document, and then you have to like create a question answer. Like I said, it's a hectic one, right? It's not like simple you will write a code and then it will prepare. No, you have to go, you must be having a subject understanding. You have to involve people, right, for a cross check, because this is how your code will understand that what will be the question, what will be the answer. Yeah, now you will say that I will go and generate an answer from a GPT. I mean, like, then you will lose the context of your own data. Yeah, GPT will give you a generic answer. Your data is having some like specific to your company, right? Policies will be specific to your company. My HR policies is not going to be the GPT HR like policy that GPT is going to give it to me, right? My financial policy, my HR policies, or my sales pitch, because it's my product, right? My marketing strategy, all those things, right? All those things are like not going to be a generic one. That's, and it is not a generic one. That's the reason we are doing fine tuning, right? Otherwise, what is the need of fine tuning? Yeah. The only reason we are going ahead with the fine tuning is very simple. The existing LLM is not able to give an answer with respect to my custom data. That was the whole reason. So in that situation, so this is kind of a hectic task actually. This is not like a easy task, and obviously team will be involved, functional people will be involved, domain expert will be involved over here. It takes time. It takes time always, because you have to do a vetting of every data set, right? Because if this question and if this answer is going to be wrong, then obviously you can't expect a correct answer from your model. As simple as that. Means always we need a already existing model with the fine tuning, then only model work according to our organization. So always need a existing model with a fine tuning. Yeah, the good one, the best one, right? This is called as fine tuning, right? Otherwise, you can do a training from the scratch. That also I have taught in so many classes. So you can try to train the entire transformer on your own, and like starting from like a scratch, basically consult with HR team, sales team, then yeah, everyone, whoever is a part of like the process, and for whomever you are creating a model, because I'll create one model for my finance team, HR team, I'll create one model like for every department, even in one single department, maybe multiple model. This is how we are shipping a model nowadays, right? This is how we are doing it. So redacted, so introduce a bias towards the correct result instead of hallucination. Yeah, basically. So we are trying to control the hallucination over here. That means there is something called as like we are saying that okay, learn this and unlearn this. Unlearning is also a learning process. This is what I'm trying to say. Data preparation will save our job. It will be a huge task. Generally, juniors does that. Every company, right? Even OpenAI kind of a company, they have a big like a team, and mostly they used to even outsource those jobs, right? So where like a labor cost means engineers cost. That's a labor market, right? For IT industry. So where labor cost will be less, so they try to just outsource those work to like those countries, or maybe you can say those teams. uh, they just try to like observe it so that they prepare the data. Yeah, it's a big industry in itself. Data labeling is one of the like a very big industry. It's a data annotation, yes. Interns from low price country college, yeah. And it's a like people used to hire massively. If you look back maybe 3 or 4 year back, right? uh, Maybe you guys were not a part of data science industry or something, but yeah, if you can go and ask someone who were already a part of data science industry, you will be able to like see that they will tell you that okay, so it's a very big industry, and it's providing a job to not just 1,000 people. So like 10,000, 20,000 people are working in like one single team, and they are doing day and night one thing, like data annotating, data labeling. Because to train even like self-driving car, I need like all the object labeling, teeny tiny object labeling, right? Then I can build a best of best vision model. Same goes for NLP. So just imagine, to train like a GPT kind of a model, how much data preparation they have done. So obviously in that, because it's like it's aware about the world's data, right? So like just imagine how many people were required, and what kind of a checks, scrutiny, all those things are required. So a huge management, a huge data labeling, annotation team, everything is required for that kind of a model, which they have to like train it from the scratch. Nowadays, almost all the data set we are able to label. So yeah, specific to a particular, like in a particular project itself, you will get that job. But yeah, like as a data labeler, so even that job is somewhere like nowadays reducing, because we are able to label most of the data. That's the reason, so we are able to create best LLM model. But yeah, it will be in picture all the time. It will be required. Maybe not with the same kind of intensity that was there 2 or 3 year back, but yeah, it will be required. It's a raw data used in pre-training, right? Depends what kind of a training I'm trying to do, right? Depends. So what kind of a training, what kind of a model I'm trying to build. So I'm trying to build maybe a question answer generation model, or I'm trying to maybe build like a language translation models, right? It always like a depends nature of the training that we are supposed to like, or we are doing it. Okay, so now let's go ahead. So this is basically a data. I believe our understanding with respect to our data is pretty much okay, right? Then we have to choose a model, right? So once my data labeling is done, so type of fine tuning. So let's suppose I have decided that I'll go ahead with the full fine tuning, right? Or maybe I'll go ahead with the Cora, LoRa, or maybe a DPO. Then I'll do a data preparation accordingly. Then obviously I'll choose the hardware side of it. So as of now, I'm going to do a training in my local. Like I said, yesterday it took around like 1.5 hour of time for me in terms of training. Then I'll try to prepare a code and infra. So here, when I say code, before that, So we have to even prepare a base model. So which model I am going to choose? So base model, right? So which base model I am going to consider and which base model I will be fine tuning. So here you will be able to find out in my code base. So I have just separated all the file in a very clean manner. So full fine tuning, LoRa, Cora, Prefect. Just go to any of these code bases. I am using a very lightweighted model called as Tiny Llama 1.1 billion Chat V10 model. So this is coming from a Hugging Face, right? It's an open source model. I'm just trying to basically use this particular model everywhere. You can try to use GPT OSS 20B, 120B, any other model, any other LLM models, you can try to use it instead of using this particular model. So this is just a base, one of the base model I'm using. You can use like all the like models out there, and it just depends upon you. If I'll talk about this entire training part, it's very easy, believe me, right? It's very easy to understand. Let me give you the explanation, and it's not at all tough to understand. So code wise, it's nothing, believe me. It's just a configuration. Means prepare the data, select the model, set a parameter, training parameter for the model, done. So code wise, it's not at all difficult, believe me. So preparation before, like whatever preparation that we do before, that's a major part. But yeah, putting something for a training on my local hardware or on basically like a GPUs, it's again not a big deal. Anyone can do it in a easiest possible manner. So let's try to take a understanding. So let's suppose I'm going ahead with a DPO, right? Like a direct preference optimization. Now here, so I have prepared basically a finance data for a DPO. So if I'm doing a DPO fine tuning, DPO based fine tuning, so I'll be using a finance data, right? I have already named it in a very clear manner that for finance, I will be using DPO. So let's suppose this is a DPO code for doing a fine tuning. So data is already been prepared, right? Data is already been prepared. So here I have written a simple function to load a finance DPO data set. So I'm trying to open up a file, as you can see. So with open file in a read mode, right? And load the JSON data. So this will lead the entire JSON data. Now inside my DPO data set, I have what? I have prompt, chosen and rejected. These three things I have four things actually. Input I have, but yeah, input is a context, and I have kept input as a blank everywhere. So I'm not going to consider it. And like I said, so I can do a key value mapping. So again, these names doesn't matter. So I can like give some different name. That's okay, because anyhow I'm doing a mapping over here, right? But context, intent should not change. Intent should not change. Prompt means instruction, chosen means the correct answer, rejected means the counter one, right? So intent should not change. Name, you can like give any kind of a name, any variable name, doesn't matter at all. Even in your JSON file, you just have to do a mapping so that system can understand. So here I'm trying to create a three like a empty list, as you can see, and then I'm running through a data, right? So whatever JSON that I have loaded, technically this JSON which I'm going to load, where I will be having prompt, chosen and rejected one. So I'm just like trying to go through this JSON one by one, data one by one, and then in a prompt list, I'm adding prompt. In a chosen list, I'm adding chosen. In a rejected list, I'm adding a rejected. And then it is going to return me a data into a dictionary format, right? Dictionary format. So this is what this function is doing. I believe this function is pretty much clear. I believe one of the easiest Pythonic function you must have seen in recent days. Yeah, one of the easiest one, right? Just like a story. I think anyone can understand, anyone can write it down. Yeah. Okay. So this function will take your file path only. So wherever your data set is, maybe on some server, maybe on some drive, maybe on S3 or whatever, right? Read the data and then like finally give me the dictionary of it, right? Dictionary out of it. So maybe my data could be available in a JSON format, let's suppose. Maybe my data is available into a text file, let's suppose. My data set is available into a CSV file in a Excel sheet. What I want this kind of a data, dictionary format of the data set I am looking for. Is it making sense to all of us, guys? Yeah. So in this format basically. Now again, people will ask me a question that why? I mean, like the simple answer is why your name is XYG. because someone has already defined. So those who have created these like a, this like a training functions, right, a trainer function, basically they have defined that whenever you are giving an input to me, or you should always follow this rule, that you should always convert your data in this way, and then you I will, it's not like you will just like read some scrap of the data in any format and then dump it, and then system will be able to understand automatically, right? System will never be able to understand. System is not having that kind of a capabilities. It will only understand the instruction that you are going to give, which is already predefined. So this kind of a data I'll try to give. So it doesn't matter in which format I have my base data. So I could have kept this data into a JSON, I could have kept this data into a TXT, I could have kept this data into a CSV, Excel, maybe into some other databases, maybe into Mongo, Postgres, Cassandra, whatever, right? Doesn't matter at all, right? Ultimately, I have to read those data and I have to finally prepare my data in this format. Is it making sense, guys? So someone has asked me a question that do I need to prepare always a JSON data? What is the answer? Yes or no? No. I need this format of data. So finally code it, do it. Yeah. So I think that part is clear now, right? That JSON data is not required. Doesn't matter, like in whatever format you have keeping a data, keep it, right? I just need three things: prompt, chosen, rejected. If I'm doing a DPO, right? So these three things are, three entities are required. I'll just like and then finally read it from some like any other places, and then finally prepare the data set into a dictionary format by using maybe this data set library. Okay. Now moving to the next part, right? A training part. Now to do a training, right? So this is a function, right? This is a function. So here to do a training, basically, I have to give a data set, part number one, to do any kind of a training. I have to give a model, a base model, and then after a training, model will save somewhere. Yeah, model will be saved in some directory, all the files, model files. Then epoch, how many times we are going to pass the entire data, right? Then a batch size, basically, so how many data will go in one single like a run. Then a learning rate, I believe we all understand this like a learning rate parameter, and then the beta. So again, coming from your like optimizer itself, a beta. So here these are the input which is required. So this is a function we are trying to create over here, and one by one, so we are trying to give this as a input, right? So those again who is having a question with respect to this dataset library, so basically this dataset is a library, so which will try to convert a data into a Hugging Face compatible dataset object. This is what this dataset library is trying to do. So those who is having like a question on that part, yeah, simple. Okay, so here what we are trying to do. So basically there is this function. This is just like a basically like all this base model name. What is the meaning of output directory, epoch, batch size, all these things just as a like write up is mentioned. So just doc string you can say, right? So this is our function name. Now what this function is trying to do? So basically this function is trying to call auto tokenizer. Yeah. So this function is trying to call auto tokenizer from pre-trained and then a model name. So whatever model name you have given, this let's suppose I have given as a model name. What it will do technically, so it will try to download that model. Yeah. So it will try to download that particular model. So that I will be able to do a fine tuning of that model. And then we are trying to do end of the sentence tokenization, so that we are trying to make sure that there should not be any kind of a missing padding available inside the model. Means the length of the model should be like or length of the entire embedding should be like same, by the way. Then auto model from a casual LLM from a pre-trained. So we are giving a model name, we are giving a device mapping over here. And then we are trying to give basically a low CPU memory use is equals to true. Now we are trying to give a device mapping auto, means if CUDA is available, CUDA means if my GPU is available, right? So just try to use it. If GPU is not available, then try to use a CPU. So I have given both the instruction. I was trying to train it. If you are training it in a GPU, then you can remove the auto part, just give a CUDA part, right? Because it will be having a GPU. In my system, I have a CPU, I have a GPUs both. So I'm just giving an option that okay, fine. So choose whatever you want, whichever is available, right? Whichever is best available at that point of a time. So just try to choose it. Again, you will be able to control the uses of your resources, your hardware. This is like something which I'm trying to do with the help of this one, and hope this is making sense to all of us. Yeah. So a multi GPUs is available, right? Okay. Now, so this is just a hardware. Then coming to the like this one. So auto model from the casual LM from the pre-trained, same thing, model name, this. It seems I have repeated this things two times. Yeah, I'll just remove one. Maybe while doing a copy paste, I have copy pasted twice. Yeah. Okay. So again, torch CUDA is available means if GPU is available, this is what it means. So model dot half. So if CUDA is available, save my RAM. So this is what like half means over here. So save my virtual RAM memory. So in this way, I'm just trying to set my system preferences that okay, whenever you're trying to train my model, maybe use a GPU, use a CPU, and then take a decision automatically. Then the main part is training argument. So what are the training argument that we are trying to give over here? So output directory already coming as a parameter, right? That okay, where you have to save the model. So I can give any path, any directory wherever I would like to save this model for this one. So this output directory I'm trying to give number of training epoch. So how many number of times I would like to pass the whole data. Batch size again as a parameter I'm trying to give gradient accumulation step. So again, this is one of the parameter that we are trying to give over here. Then like a learning rate, LR, CUDA. I'm trying to say that, okay, if like CUDA is available, just use it. Save strategy, epoch. So basically save strategy is nothing but a kind of a checkpointing. So basically for every epoch, I can try to save the model for the best of the, the output or best of the like a loss, I can try to save the model. So here epoch wise, I'm trying to save the model. Logging steps, so after every 10 steps, just try to log in. Warm up steps, so after every 50 steps, just try to this one. Optimizer, so I'm trying to use a Adam optimizer over here. As you can see, optimizer is required to calculate the loss and like, accordingly a gradients. Save total limit to, so total like a 2 max to max model you can try to save. Report to none, no need to do that. Remove unused column false. So this is a training parameter and accordingly you can try to adjust your parameter. If your epoch will be more, if your batch size will be more, so obviously it is going to affect your memory and the training time. And accordingly you need a hardware scale, right? And I think we all understands that, right? In every deep learning concept, so we keep on like talking about this Adam optimizers, by the way, our loss functions, our learning rate, each and everything. So these are just a training parameter, right? Training parameter we are trying to set over here. Then these are the generic training parameter. Then coming to the next part, as we are doing a DPO, right? So system is supposed to understand that we are doing a DPO. Now for DPO, we have a library, by the way, right? We have a library over here called as DPO trainer. And with the help of this library only, you will be able to say that, okay, I'm like, basically doing a DPO kind of a training, a direct preference optimization kind of a training, which is nothing but a transformer, right? Transformer for doing a reinforcement learning. So with the help of this library, you will be able to like say, so for DPO, you have to set certain parameter because these parameters are just a generic one, right? It goes with everyone. So if I'm doing a DPO, so I have to call a DPO trainer model, whatever model you are going to give, reference model. So you have to give argument. So all the training argument means this entire things will go inside this argument part, right? Training data set. So data set directory. So whatever data set directory that you have like a given, so you have to like load, use this load function. It will return the data set in which format? In this format. Then only DPO will understand that, okay, fine, this is the data, this is the format. So here we are trying to give a input to a DPO that, okay, load it and then give the data set. Tokenizer. So again, we are trying to like call our tokenizer over here, EOS tokenizer, so that it will, my entire data set will be converted into a tokens, numeric value, because without system will not be, I'm giving input in a English language, right? But system will understand what? System will understand technically a numeric value. So this is what we are trying to set there, tokenizer. Beta is just a KL divergence value we are trying to give. Maximum prompt length is 26, maximum length is 512. Means maximum input length is this, maximum length as an output will be this. Something like that we are trying to set it over here as my DPO parameter. Yeah. So this is and if my prompt and if my like output is greater than this, it will try to truncate it. Yeah. And both is mentioned inside my data set itself, that this is the input, this is the output, right? And then the counter one. So if something will be more than that, chop off. Yeah, chop off simply. So this is basically like a total length I'm trying to set that. Okay, fine. So you will be able to take input as this much and output as this much you will be able to take. Okay, again that depends upon the model. So if model like can understand the longer context, you can try to give a longer one. That's okay with all of us. Now this is the main part where it is digesting everything. My model, my all the parameters, my data set, my tokenizer, my maximum output length, input length with the help of this DPO trainer. After that, nothing to do. Just call dpo.trainer. Simple. I'm just trying to print all of these things, all the parameter, right? But yeah, nothing to do. You just have to call a dpo.trainer. It will start a training. Once training will be done, and even during a training, right? So here you can try to define your output directory. So where it is saving the model. As simple as that, and return the output directory. Is it making sense to all of us, guys? So this is what a function is trying to do. Yes, a reference model is nothing but a frozen model, the model which we are not like a changing. This is what it means. Means the original download of the model. That's called as a reference model. Yeah, fine. So I think code wise, it's not a big deal, right? Code wise, I don't think that it's a big deal for any one of us to understand. Yeah, we're just setting up the parameter, loading the same data, and then converting the data into the format which is required by the model. And then, we are trying to set the parameter, right, as per the training. And we understand all of these parameter one by one, one by one, one by one. I can change all of these parameter as per my need as well, right? And then we are just trying to call the training part. That's it. Now let's go ahead with something different. So let's suppose I'm doing a full fine tuning, right? Let's see what kind of a changes we are going to observe. I'm just trying to call all of these things. Yeah. So auto tokenizer, auto model for the casual LLM, training argument, trainer, data collection, all those things I'm trying to import. Now data loading wise, so load a HR data set. For example, I'm using this HR data set for this full fine tuning. So where we have instruction and we have a output, right? Instruction and output in this format, my data set is available. Let's go ahead with full fine tuning, right? So here we are trying to access the file, as you can see, and then in a dictionary format, same as my DPO, right? Same as my DPO. So in a dictionary format, I'm trying to return the data. Yeah. So my data set can be available in any format, not just in JSON, maybe in any other formats. I have to read it. I have to convert it in this format, return the data. So I have just optimized this load HR dataset function even like a little bit over here for the understanding purpose. And then tokenization functions. Tokenization means basically convert my data set into numeric, right? So return tokenizer, example text truncation true, maximum length is equals to 512. So if my sentence is more than that, chop it off, right? Padding is equal to maximum length. So if my sentence is lesser than this, then add 0, 0, 0, 0, 0. Some padding, just try to add it. This is the meaning of it. So tokenization function. Then I'm trying to set the parameter. So data set. So HR data set you are supposed to use. So wherever my data set is available, model, same model I'm using. Tiny Llama 1.1 billion parameter model. Output directory. So where you have to save the model, epoch, batch size, learning rate. Same thing I'm trying to give in this function. Now let's go ahead, right, and try to understand. So most of the parameter you will be able to find out is the same. It's not like different over here, right? Even model name, like where I'm trying to load the model, right? It's same. CUDA and all those things are again same. So I have not changed at all, you can say. So tokenization and everything we are trying to do. Now here, even trainable parameter wise, nothing has changed. If I wanted to change it, I can change it, but yeah, nothing has changed over here, right? Now, data collector, right? So we are just trying to like a data collector for a language modeling. So we are trying to call our tokenizer itself. So this will collect the data. And then we are trying to call a trainer inside that model training argument. So whatever argument that we have set over here, and then tokenized data set, numeric data set, and data collector. So everything we are trying to pass, and then trainer dot train. Simple. This is basically a full fine tuning. Yeah, this is basically a full fine tuning. So full fine tuning means change all the weights. So technically you don't have to define anything additional over here in terms of full fine tuning. Now let's try to understand this LoRa fine tuning, by the way, because LoRa is nothing but adding a parallel layer, right? And then we are trying to do some sort of a training over here. So here LoRa fine tuning I will be doing with respect to a healthcare data set. Data format is same, dataset.dictionary, right? So data format is like going to be same. Here you will be able to see that I'm loading one library, a pfet library, right? Parameter efficient fine tuning, because LoRa Cora will be a part of pfet itself, right? So get pfet model, LoRa configuration, task type. This is going to help me out in terms of taking a decision that, okay, go ahead with the pfet, go ahead with inside a pfet, go ahead with the LoRa, go ahead with the Cora. Full fine tuning means not required, right? Follow the regular approach. DPO means DPO trainer I have to use, right? So that library is already available. Now, here you will be able to find out that all those things are same. Tokenizer is same, load data set is same, this function, right? So here, loading a data set, same model I have not changed. I'm defining a directory. So where I have to like, store this one. Epoch, I can make it up and down. So LoRa R configuration and LoRa alpha. So these are two parameter which is required actually for doing any kind of a LoRa training. So if these parameters are not available, you will not be able to do a LoRa just for the LoRa. So basically LoRa rank. So LoRa is nothing but LoRa rank. And then there is something called as LoRa alpha parameter. What basically this one in a layman way, if I have to explain you, so this helps us out in terms of basically, I told you, right? So this is a parallel layer, right? So what by what means n cross m, right? It is going to be a matrix, right? When I say weight, it should be a matrices. So by what matrices, what will be the matrix dimension I am supposed to pick and choose over here? That is something that we try to adjust as a parameter. So I'm saying that 16 cross 32, something like that, I'm trying to define. I can play with this parameter. It's completely under my control. So basically, this is a decision making parameter for your network, the parallel network that you are trying to add. So you can try to add a big one, you can try to add a small one, because as per that, and this is where I told you that sometime I'll try to explain you the mathematics behind it, so that you will be able to understand this actual metrics like a size calculation. It's a small mathematics. Maybe next class I'll try to teach it, or maybe you can watch my previous lecture from a previous generative AI series. I have already explained that part as well. So training a parameter. Now here tokenization is same, not changing anything. Model is same, not changing anything. This one. Now here, so basically we are talking about a LoRa configuration, right? So here we are talking about the LoRa configuration. So task type casual LLM, R basically rank is nothing but a LoRa. Then we are trying to like set a LoRa alpha, LoRa dropout ratio. So when it will try to do a backup propagation, means the small network what it will train. So we always try to adopt back dropouts, right? So that just try to make zero or make it silent some of the weights, so that it will be able to learn in a better way. Target module is basically a Q LoRa, and then like a V LoRa, and then like a P LoRa. So basically, right? So here target module name that we are trying to give over here. So basically it should match with my base model, right? So if I'm using a llama model, if I'm using a T-Llama model, basically, so it depends upon what kind of a architecture, the base architecture we are using. So if you go and check, it is basically my llama series. So tiny llama is something that we are trying to use over here. So these are the target modules which is like aligned with my the base models. And again, you can try to like do a search that, okay, if this is my target model, then what target model, then what should be my target modules for this model in terms of a LoRa. Bias is none. Now If your architecture is going to change, then this name is going to differ, by the way. So there is something called as wpack, a query key value. This is something that we try to put as a target module, but as of now, so Q project, B project, K project, and O project. This is something that we try to give. So query key and values, basically, right? And then output. This is my target module, means target computation, basically. Now, so here we are trying to call a function get prefet module, and we are trying to pass a original model, and then we are trying to pass the configuration, right? A LoRa configuration, the configuration that we have done just specific to the LoRa. And then we are trying to basically give a trainable parameter. This is just a calculation we are doing so that I can show you that, okay, so how many parameter we are actually training. So for example, I can easily find out what is the total number of parameter in this one, and which I have trained already in full fine tuning, right? So here, just to show you in my like a run. So when I'm going to run it, right? So just to show you, this is not required for the training, by the way. So, but just to show you that, okay, how many parameter we are actually training versus the original number of parameter, means how much like we are able to save, right? Of fraction. And you will be able to find out like a 99% we are able to save, basically. Uh, so just to like do the print, we have done this one. After that, nothing much. Simple, call the data set, call a same trainable parameter, which we have done, call a data collector, and then call the trainer. Trainer means just try to pass model, training architecture, tokenize, data collector, and then it will try to call trainer.train. As simple as that, right? Everything is connected, and then save the model. Now, this is what happens in case of a LoRa. So just like DPO, in case of LoRa, so I will be having one more additional configuration, right? So which will help me out in terms of adding a parallel layer to my model. Again, if I'll talk about Q LoRa, quantized LoRa, right? So here I'm trying to, calling a pfet. Again, from a pfet, you will be able to find out, prepare a model for K bit, n number of bit. I told you, right? Quantization means what? Reducing the number of bits. So here I will be having a control that, okay, I can reduce it to a specific bit, maybe 32 bit to a 4 bit, or maybe 8 bit, or maybe to a 16 bit. And you will be able to find out again one additional parameter to maintain this one. So here load in 4 bit. I'm trying to call this like a bits and bytes configuration, right? And I'm saying that I am trying to create a model, and that should be available in a 4 bit. So NF4 quantization I'm trying to use. I can go ahead with 8 bit as well. I can go ahead with 16 bit as well. I can go ahead with any other bits. That's like a completely okay with me. But yeah, so it's just a bit control that we have to do. So this is what we are like trying to do over here in terms of configuration. And on top of that, we are trying to call a LoRa, because when I taught you like a Cora, so what I have written, it's a quantized LoRa. So LoRa configuration will be there, and plus quantization configuration will be there. So quantization configuration for a bit, basically. So convert 32 or any bit into 4 bits, and then for a big model, and then there will be a parallel layer. Parallel layer means to understand my data set. So this model will be reduced in the size, and then there will be a parallel architecture which I'm going to train with my own data set, so that it will be able to balance the generalized and the specific data set altogether. This is what we are like trying to do over here, right? This is what it is trying to do over here. Nothing much in terms of, like output I'm trying to change, by the way. So yeah, so this is like, so code wise, all this 4 or 5 code which I have written, so it's actually same as per the specification. We are just trying to add a layer, that's it, a modular layer I have added. And I have also kept it in such a way that you all will be able to understand anytime, maybe even after 2 year 3 year, you will be able to understand it. So no class and object kind of approach I have used over here, because that makes a code unnecessarily complex. I have just used a variable declaration and, functional approach, so that, things will be pretty much modularized, separate, and you can call anything into anything. More I will be talking about it in depth and detail in my next class, which is going to be on a Saturday. But just now, quickly I will run it. right? Quickly, I will run it because I have already trained my model yesterday itself. So my model is available. Everywhere you will see I have a checkpointing, right? I have a checkpoints which is available. If you are going to train the model, so again, it will take a time for you. I'll share the code base. Just delete the entire model available file and then you can try to train it. I'll just show you the testing part, by the way, because that is going to be interesting. Yeah, that is going to be the interesting one. So here for a testing, I have a module I have created where I'm passing all different kind of queries, HR queries, finance queries, okay, sales queries, fine. So here, what I will do, so I'll try to write Python. It's not API. I don't know how to, I don't want to do API testing for now. I've even converted that as an API. So I just wanted to do a testing. Today, just try to learn and observe. Don't do anything. So test model, test, not API. Test model dot py. Yeah. So let's do a testing of this like a model, basically. So here, see, I am the query. So testing means what? I'm trying to do a testing of different models. So full fine tuning model, it is able to select, right? It is loading a model from my HR like a model directory. And then it is asking a query. How do I apply for a casual leave? That was my question, right? And somewhere I have already trained on this particular question. So there must be some answer, and answer should come from my data, and that too in a proper formatted way which anyone can understand, right? So let's see. It is taking time because I'm doing a inferencing in my local system, and if you will see my let me show you my, yeah. So here, how do I apply for a casual leave? Response is to avail a casual leave, you need to present your leave application from form 19. Now, form number 19, it's not a generic data. It's coming from where? My data, right? Because if you'll go and ask your chat GPT, they will not give you form number 19. What is form number 19, right? Basically, it's my company's policy. So form number 19 is my company's data. At time of reporting to the work, you will guarantee up to 6 days of leave per month. Leave must be taken on a pre-booked basis and not on a casual basis. Leave will be paid at the rate of 50% of your regular pay. All this like, and this output looks great to me. It literally looks amazing to me. Yes, everyone? Yeah? It actually looks great, right? I have taken like small data, not very small. I have a sizable data, I can say, sizable number of record. I have just trained it for 2, 3 epochs, not more than that. Because if you'll see my parameter, trainable parameter, which I have shown you, somewhere I'm keeping 5 epochs, somewhere I'm keeping 3 epoch, somewhere I'm keeping 4 epochs, right? As per the training and accuracy that it has given to me. So I have like modified that part basically. And yeah, it's just in 2, 3 epoch. If I'm going to train it for 100 epochs, maybe on more data set, maybe it will be like it will work better than this. But yeah, even with this epoch, it's behaving like a good, and yeah, it is able to give me like a very good response. Inferencing is slow because it is going to my model, and then it is trying to do the inferencing. Here I'm trying to like test some prefect model. Yeah. So if you'll go and check my task manager as of now, so my CPU, my entire compute is going very high, as you can see. So my CPU is like 57%, my memory is 43%. I'm doing a inferencing, right? So just see how my CPU is behaving. It's like fully occupied. Yeah, it's fully occupied. My CUDA number one, so almost like 14%, 15%, it's running on that. GPU number one, GPU number zero. So yeah, it is able to use something. But if I'll talk about my memory, so my memory is high, my CPUs are like super high, right? All my like a core is like a, and processors, logical processors are super high as of now. Because inferencing is a tough task. Still is doing inferencing. I have written so many queries. If you look into my test model queries, right, I have given all the queries with respect to all the model. And with every model, you will be able to find out that it's behaving in a beautiful manner, right? How to handle a delivery delay complaints, right? So thank you for your feedback. We understand the inconvenience you are facing and apology for a delay. We are working on resolving the issues, providing a solution. Please provide your order detail. So whenever someone is like saying that so as per like my uh, you know data, it is behaving very good, pretty much good, right? It is able to give me an answer. And yeah, all these answers are actually with respect to my data, because if you'll read out this answer, it's not a generic one. It's not a chat GPT's answer or pre-trained LLM answer. You will be able to find out. You will be able to find out same answer in your data set. Yeah. So LoRa model, Cora model, what is this? So basically LoRa model is trained on healthcare data. So what is the symptom for the dengue fever? So can vary, but include fevers, severe headache, muscle pain, joint pain, vomiting, and rashes. Yep. So performance of my model is actually like a great. Yeah. And explain the EMI option for a laptop purchase. Now this data is actually coming from where? My data set. 2.99% of like EMI or interest you have to pay. Everything is coming from my original data set. So I'm able to train in my local system, right? A good model, by the way, which I can actually use for my like real time purposes, right? Everyone, yeah. I'm just trying to show you the output, the authenticity of the output. Yes. And then what I have to do, I have to test this model here in local or maybe wherever I'm training it, and then I have to migrate this model on a final server, because here I have a limited compute, so inferencing is taking a lot of time. Maybe I can try to Quora output will be quick, so QLoRa output will be quick this time. And again, so you will see that my compute will be decreasing when it will call the Quora, QLoRa, quantized LoRa, right? So maybe I can try to like host it on some like a higher instances GPUs, right? And I can just like attach with any system out there, maybe some chat system, maybe some document summarizer system, anything, WhatsApp, Telegram, whatever I want, I can try to integrate those output. Person will ask, person will get the answer. So my HR department, my sales department, marketing department, my finance department, all will be live and ready to give any kind of answer. Yeah, that we will do next week. We will bring all the model online. Online means anyone can use it in this entire world, from their Telegram, from their WhatsApp, maybe, yeah, from their chat interface. And you can even use this model for any other purposes, maybe for like agentic purpose, for RAG purposes. We have a LLM, right? So I can just try to like use LLM in hundreds of other ways, not just in a chatting ways, but yeah. So we'll try to bring our entire department live, all the department. If query is not in our data set, then what output will get? It will give you some vague output, right? As per its own understanding, because anyhow it's a generation model, right? Generative model. It will generate some output. It will generate some English text. Kind of update less, learn. Kind of update less, learn more. I'm not able to get your comment, Yogi ji. What if I want to answer from only the trained information, not from the default LLM trained data? Then you are going to make a blunder. I'll tell you the reason why you're using a pre-trained model. See, your pre-trained model is not specific to a particular domain. It understands the meaning of a grammar. It understands the sentences. Anyhow, you are trying to give a data in English or maybe in some languages, right? So you need a base weight which must be able to understand the grammar. So if you are not taking an output, if you're not considering your base LLMs, in that case, I have already taught about like a training a vanilla model or training a model from the scratch. Just go there, and the kind of a result it will give you, you will not be able to understand. It will give you result. I'm not saying that it will not give you result. It will give you result in English itself, but grammar and all those things will be like missing. Grammar, relation, context, everything will be missing, right? So we need a LLM model. We need a base model. Yeah. Testing completed, and yes, this is a amazing answer everywhere I'm able to get from all of my models, right? So this entire file will be available. I'll just walk you through this entire file once again. But if you look into these files, it's not at all difficult to understand. I believe we understand the core concept, right? And going forward, even in your company, if you are going to do a training, use it directly. No need to change anything, right? Prepare the data. So everything is going to be actually same, right? At least for these many kind of a fine tuning which I am teaching you. So nothing is not even maybe single line you will change. You will change some parameters. That's it, right? And if you are doing a training in local on cloud, everything is fine. Yeah. What is a frozen model? Frozen model is the original model, the model that we are downloading from Hugging Face library, right? We have given a model name, right? That's my frozen model. This one. Yeah. What needs to be done if you want to get an answer on a different language? So basically, you have to pick and choose that kind of a model which has been trained on that many languages. And then even you have to give your data set in that many languages. How can we use two or more model as a base model for a fine tuning, or only one? As of now, only one. Yeah. Okay. So this is it from my side. Just try to digest. Just try to go through this one. Believe me, you will enjoy. You will enjoy this entire like a code base, as well as like this entire application that we are trying to create. Don't try to understand any other files. I'll give you the explanation. Yeah, I'll give you the explanation. Most of the file I've created it for the testing purposes because I was getting like a lot of issues. I have fixed all of those issues. Plus, I have even like created an API. Plus, I have even created like a something where I can host the entire things on H100 and then do a inferencing. That I'll show you in a practical manner. Everything, even training, I'll show you in a practical manner. I'll just copy the entire instance in some other directory and then I'll show you the training, because training itself will take you like 1.5 hour. Yeah. So it will, because we are training 5 to 6 models over here, not just like one single model we are trying to train. Even we are training for 2, 3 epoch. Any security breach in a company if we use this code base model, what will be the I mean, like, look into the code. Why you are even asking this question? Whenever I discuss something, right? So people nowadays, I can see like people ask couple of questions very quickly, like security, how safe it is, and then like a scale. I mean, like, look into the code. What is the security breach? Everything is happening in your local system, right? You're just downloading the model, data is yours, instance is yours. Now, what will be the security breach? These questions are just a dumb question, I would say. So please share the code base URL if any have already shared. No, I have not shared this one. I'll just upload it inside your dashboard. So once I'll upload the recording and then you guys can go through it. Take your time, right? Take your time, digest it. But yeah, don't try to understand all the other files. Other files, I'll try to explain it to you. Yeah. A lot of file are testing file. I'll just delete these files. Testing files are not required. Not all the testing files are required. Just couple of and then even I was trying to deploy these things in 2 to 3 ways. One is a Docker approach, one is a Kubernetes approach. I'll try to show you Docker approach, by the way. Even I can show you Kubernetes approach, just a command, in terms of like doing a deployment on single instances or in a multiple instances, and exposing your model to the entire world. How we can integrate model in our chart UI, that we will see next class, not now. Yeah, that I'll teach you in upcoming classes. Once we'll deploy this model on some cloud platform and make our model live. As of now, it's only working in my machine, so we can't make it live. Yeah, ngrok is one of the option which we have, but that is not a final option. So we'll deploy our model with the help of Docker or Kubernetes, and then expose it via APIs. And if something is available as an API, I can try to just call the API in WhatsApp, in Telegram, in my Yuri kind of a chat system, and bingo. So next class, what we will see, that we are trying to make all our departments live. Simple. All the department will be live to the world. So this is it, guys, from my side. If you have any kind of a question, raise your hand. I'll try to unmute you, and then you can, like, go ahead with your question. Just raise your hand. Yeah, and hope all of you have enjoyed today's class. Yeah, you all are able to understand little bit at least with respect to, like, fine tuning. Today's class was complex, is it? I mean, like, in last half an hour, I have talked about a code. Before that, I was just talking about a theory, like, behind that, behind the scene. Yeah, Rakesh, go ahead.
Yeah, sir, can you just explain one more thing? The difference between the full fine tuning and the DPU. Actually, I think both are looking similar. Like,
See, DPO and the full fine tuning means we are trying to train the full models, right? The
yeah.
only thing is in terms of giving a data set. So in case of full fine tuning, so what we say that this is the instruction and this is the output. In
Okay.
terms of DPO, so we are trying to just change a learning approach little bit.
Mm,
Learning
right.
approach. So where we
Yani,
say that okay, this is the data, means this is the input instruction prompt, you can say, right? This is the output. But when you are trying to generate this output, also try not to generate the other one.
correct.
Yeah, so rejected one basically. So try to always select the chosen one. So basically, it's a reinforcement. So it's just a way of, like, a approach of changing the training process. That's it. Nothing much.
So I think, sir, just I've gone through all these things. So all the things is depends on totally on the data preparation, right? And
I mean, like, data preparation, then a model selection, you have to, like, depends, then kind of a training that you are doing it. Because again, when I say data preparation, so my data preparation will be different for DPO. My data preparation will be different for, like, a full fine tuning, right? So data preparation is one thing, and then my, like, a model selection, then obviously my hardware selection, type of the training. That is the reason. So I have mentioned clearly over here this flow.
but what is mean by model selection? It means, I mean, if we have a
What is
all,
your base model?
yes, but all the base model is, I think you told earlier as well that all the models respond the correct one if you are trained correctly, right?
No, no, no. Base model means what is a pre-trained weight you are trying to take. So whether you are trying to take a chat GPT based 120 billion parameter model or 20 billion parameter model, Llama model, Mistral model, DeepSeek model, which
Okay.
model basically? That is something which has been labeled as a base model, right? So if you will look into my code base, which I have explained to you. So if you will go and check what is the base model which I am using over here. So I am technically using a Llama, tiny Llama series,
Okay.
this base model, right? So this is
Hmm.
already a pre-trained model. I'm downloading it from a Hugging Face, and then I'm trying to use it in my, like, fine-tuning approach. So this base model also matters a lot. If your base model is maybe GPT OSS 120 billion parameter model, it's a big
Hmm.
one. My entire system will crash. I'll not be able to train 120 billion parameter model in my local system at least. Not even with the one single H100. I need like 3 to 4 H100. So it depends
So
upon my base model as well.
so how we can I mean give the instruction to our organization that we need this type of system configuration for doing our the model best.
Yeah, so basically,
There-
if you have selected a big base model, right? If you have selected a base model, so obviously you must be aware about the parameter. For example, when I say GPT OSS 120B, simply means that I need there is a 120 billion parameter model, right? And then when I say 20B, 20 billion parameter model, now to train 20 billion parameter model, so I can check the specification. So maybe a specification has given that I need a 2H100 at least, or maybe A100, right? So that is the specification that we will give to our client or maybe to our, like, organization, that okay, just give me this, like, access so that I will be able to train.
I mean we need to learn those things as well so that.
There is nothing called as learning in that one, so you should always aware about it, because there are, like, a millions of models, and then when you will, like, go and check over the internet, instruction for every model will be given to you.
Okay, but if we are talking about the models, then we can consider suppose on the internet. But if we are training to our model
Hmm.
from our data, So in that case, how we can calculate, suppose thousands of images
Base,
we
first
have.
of all, base model, right? Base
Okay.
model you are trying to train. So base model is not your model. Base model is some of the public open source model.
Correct.
This is not your model, right? This is a model which has been already trained on a huge
Right.
amount of data set. So basically, this is a base model. Now you are trying to give your data set. So first
Right.
criteria should be that, okay, at least base model should run in my system. If my base model itself, let's suppose I'm doing an inferencing or I'm trying to do a training with
Mhm.
120 billion parameter model or maybe 700 billion parameter model. Now, if
Mhm.
that model itself, I will not be able to run, right?
Correct.
How I will be able to train it with my data set?
Correct. Correct.
Yeah. So my system configuration, first of all, accommodate this base model. Now, once this
Mhm.
accommodation will be done, then obviously I have to choose a delta. That what is the data which I'm trying to process. Once this will be done, then obviously my training parameter will come into a picture. My epoch and my batch size. Because batch size, if batch size is more, basically, so it simply means that I'm trying to take more of my RAM or VRAM.
Right.
Because batch means what? So that is the number of data set it is trying to set
Number.
in one go,
Yes.
in one go, basically, right? In one, like basically like a weight adjustment, or in one forward propagation in a model. Yes. So
Right.
that, so again accordingly, so I have to basically like increase my RAM or my main memory over there. Epoch, again, if I'm trying to train my model, so accordingly I have to adjust my entire hardware structure. So my entire hardware structure depends first on my base model, second the number kind of a data set, third the parameter.
Okay. So I just wanted to ask that if suppose the base model I have handled with the information that already we have taken
Hmm.
from the
Hmm.
internet, and then
Hmm.
after that, how we can calculate actually if, any formula or something like that, that if I have input my data like
See,
this MBs or.
the formula is, I think I have already talked about that formula as well, that how many CPU hours or GPU hours it will be able to take. So technically, it's a number of parameter calculation. So first we try to take a number of parameter in a consideration, then we take a batch size, then we take a epoch into a number of like a consideration, and then like a total amount of the data or tokens, basically. So once you will consider this, then there is a formula by which you will be able to calculate a GPU or CPU hours plus GPU CPU hours. So GPU frequency and CPU frequency also, or clock also matters, because every GPU will not same, right? So
Right.
H100 and A100 is not going to be same. So lump sum you will be able to do a math over there, that okay fine, so this is the GPU hours which is required, then you can try to, like, arrange your GPU plates accordingly.
So in the next class, can you
I'll talk about
provide.
that lump sum formula. I think I have already discussed somewhere in
Yeah.
my interview preparation series. Somewhere I have
Because
discussed those
it's a
formulas.
important because always we need to give the system configuration to the
Yeah,
our
Ashish
IT
has
team.
already pinged. Yeah, it was already actually. Yeah, I remember. I have already discussed that. See, Ashish has already pinged, right? It was discussed in an interview batch, because I remember I have discussed about that formula. Okay, fine. Just give me a reminder in next class. I'll talk about that formula once again. But yeah, in your recent generative AI batch, interview batches, that's the reason I keep on saying just join all the batches. It will give you a lot of learning. But yeah, fine. We'll discuss that next class.
Okay, okay, so thank you
Yeah,
so much.
yeah, yeah. Okay, Dhruv, go ahead with the question. Naresh, after that.
Yeah, hi sir.
Yeah, go ahead.
Yeah, so my question was, so there is two project. The first one is myself, of course, because I consider myself a biggest project. So
Hmm.
if I have to train data about myself, because
Hmm.
right now what I'm doing, I'm using DeepSeek Chat GPT. So they,
Hmm.
I just keep updating data based on
Hmm.
chat only, but that is
Hmm.
generic, very basic, and I cannot train on a like very large level, right? And the second project, you can say, my company that you already have to train, like the finance data,
Hmm.
HR
Hmm.
data, marketing and sales. This is a very very real use case that every company needed, but they do not start because either they do not have engineering bandwidth, or either they don't know how to do
The
that,
majority
right?
of companies are doing it nowadays. So whatever
Okay.
model companies are developing internally, right, proprietary model,
Okay.
every company is doing the same thing. Every nowadays many companies are doing it basically. It's
Even
not
I'm in the software, like we are selling software, so we are I'm into the software company. Even they haven't yet started. I know this part, like fine
okay,
tuning and all. Yeah.
okay, okay, okay.
And our use case is very huge in terms of customer support, in terms of training the team, in terms of
Hmm.
HR and all. these
Hmm.
use cases is like way more important.
Even what we do, so for our different customers, right? See, how companies are generating a revenue out of generative AI or like this new AI, wave. They are actually like creating a lot of models for a client and they are charging them huge. Believe me. And
Hmm.
technically, when I say they are creating a models, this is what they do.
Okay, okay.
Exactly the same thing that you are able to see on your screen. So, and
Hmm.
then they're charging like a $1 million for like giving them, and they say that okay, this is your model on your data set, this is your proprietary model, and
Hmm.
just charge them $1 million for that.
Okay, and that was the second thing that I just wanted to like not ask, but just wanted to add. Ki this is a real business use case also. If companies are doing, that's fine. If they are
Yeah.
not doing, then we can tell them we can do in a behalf of their department.
This is the proposal you should give to your client that okay, I'll prepare a complete proprietary model for you, a best of
Right.
best model for you, because they don't know right what goes in
Yes,
the
yes, yes.
back end. So
Yeah.
yeah.
Okay, got it. So like, okay, I think this is a better place to like firstly to understand with this code, just to
Yeah.
run my machine and just try
There
to
is
do all
nothing
that.
to understand in this code. It's very simple. I'll try to explain you once again, but yeah, nothing much to understand. Code wise, it's one of the simplest code you will see in a entire, deep learning computers and NLP, by the way. We are doing nothing except setting a parameter. That's it.
Right. So the main part will come then in the case the data part only, right? If we have to.
Yeah, the data preparation part, hardware preparation part. Yeah, hardware means you are not doing anything even in hardware. So it's like
Hmm.
you should have the access of the hardware. That's it, right? Access of the hardware. Again, model wise, base model wise, you are not doing anything. Whatever is as available as an open source, you will be picking up that. Big one, a small one, that depends, right? That depends upon my selection. But yeah, that is the model that you are going to choose, and then you will retrain the fine tune the model. So.
Okay, and yeah, and how you suggest? So yeah, of course, there will be a lot more company use cases that we will training, we will be doing all those things. And
Mhm.
what you suggest for personal case? Because what I believe after 5 year and 10 year, there will be more advancement in AI, right? But
Mm-hmm.
I do not want to go from scratch and tell them, ki, okay, hey, my name is Dhruv, I think like this, I do that. Just I want, I have one data set or kind of the in backend the kind of API. If I give
Mm-hmm.
that thing to that AI, it knows everything about me, how I think, how I thought, how was my mindset in 2025. Now how I am thinking like 2040. So that level of scale in coming time. So like uh, platform or like local how to start with that, because this is not a one day part. This is a lifelong part if I'm alive in
I
this
mean, like,
sector.
see, if your data is changing frequently, means about yourself, let's
Yes.
suppose about Dhruv, if things are changing frequently, then it's better to go with the RAG approach.
RAG.
Maybe
Okay.
till
Yeah.
today, based on today's data. So maybe you can try to train the model, and then whatever like update which will come, maybe just start putting up in a RAG manner, and
Right.
then model will be capable enough to understand your past as well as understand your current, and based on that it will be able to give you the answer. That's the approach number one. Approach number two, memory based approach, which your chat gpt is using, by the way.
Hmm.
Your
Okay.
chat gpt is already using a memory approach, right? Or even Yuri, when you use a Yuri, so Yuri can understand you, it can remember you, because what we have done, so we have basically attached a memory. So whatever conversation that you are trying to do, so we are trying to like store some sort of a summary of your conversation, so it understands basically who is who.
Hmm. Yeah. So right now, basically, because I'm working with N18, so RAG seems more comfortable and more doable for me. And the reason because I think there I can add more type of data as well, images and all
Yeah,
those
yeah, yeah. So
different.
RAG is one, and then like see this model will be available somewhere on somewhere on some like a instance, right? So
Hmm.
in the next class, I'm going to show you that how we can expose this model to the outer world, basically.
Hmm.
Means
Hmm.
basically
Hmm.
as an API. So if my model will be available as an API,
Okay.
now in a N8N just HTTPS request, right? A fancy HTTPS request.
Okay. Okay. Yeah. Yeah. Right.
So
Right.
from a N8N, you will be able to call your model, your fine-tuned model, right?
Mm-hmm.
The way you are calling GPT models, or the way you are calling Yuri model, how you are calling Yuri models, basically. HTTPS request, right?
Yeah. HTTPS request. Yes.
Same you will be able to do in the next class itself. Next class means like next Saturday.
Hmm.
Exact same thing you will be able to do it with all these five, six models. Your finance, your HR, health, with all the models.
Got it. And when you say memory, the second method, the memory method,
Hmm.
does it wrong to say ki it is just take input in text format, or we can give it in like video, image, and all the other format also, or only text format?
Generally, like we give a memory into a text format, I would say.
Text format,
Yeah,
yes.
in a token format.
In a token format, yes.
Yeah, and token could be going forward your image pixels, bytes, or it could be anything. But yeah, as of now, when we are talking about this textual conversation, so in general, we are considering a token of the textual conversation.
Okay, and I think this is where the good part with vector database and RAG, that already it converts all the PDF images and all, it tokenize at the end. That also tokenize,
It
but it
vectorize, not
vector.
tokenize,
Okay,
vectorize
vectorize.
eventually.
Okay,
Yeah,
okay,
tokenization is a part of vectorization.
okay, okay.
Yeah.
Fine. Yeah, I think this
Okay.
is great. Yeah.
Okay. Okay. Yeah. Naresh, go ahead, please, with your
Yeah, hi,
question.
Sudhanshu.
Yeah. Hi. Hi.
My first question would be like, on what basis we have to decide whether we should go for a full parameter training or, a PEF kind of training,
Hmm.
or
Hmm.
and what advantages it give or what disadvantages it gives. Like
Like,
basically, what is the deciding factor?
okay, so see, full fine tuning is something like, as its approach itself says, that you are changing the entire weights, right? You're not changing like a, you know, sub couple of weights. So when you have a massive data with a means kind of a data you have basically, so which is nowhere close to a base model learning. Let's suppose I have a base model and I have some sort of a data, but my data and base model, so yeah, base model understands grammar, base model understands the relationship between the words and tokens, that's okay. But base model is nowhere aware about my domain or my division of the data. In that case, obviously what I will do, just to get a best result, means less hallucination, I'll go ahead with the full fine tuning. But again, the cons will be, it will be a heavy approach, so it needs a more computation. For me, inferencing will be same because size is not going to change even in full fine tuning, and then in a LoRa, in Cora obviously it's going to change. So in that approach, I'll go ahead with a full fine tuning. If I have a base model which is closer to my domain understanding, right, which understands my domain, but I just have to, give just a policing, or I can say, I just have to add a little bit of information about my specific domain. In that case, I can go ahead with the like a prefet approach. So parameter efficient fine tuning approach. Inside that, LoRa. Cora, so whenever I have a requirement of hosting a model on a edge devices, right? I want to run my model on maybe a Raspberry Pi, maybe in my Android, maybe in my iOS system, right? iOS mobile devices with a limited compute and a limited, memory. So in that case, I will go ahead with a quantized Cora one. DPO. So DPO again, it's a full fine tuning approach, by the way, means we are training the entire weights. But yeah, so the approach itself is different over here. We are trying to create a feedback loop, and feedback also we have mentioned that learn this and don't learn this one. I believe I am able to give you an answer.
Yeah, yes, Sudhanshu.
Yeah.
Thank you.
Yeah.
Yeah, thank you.
Okay. Ganesh, what is your question?
Yes, sir. So training arguments,
Hmm.
these all are the parameters are fixed or it's our own defined functions.
No, it's not a own defined function. It's actually fixed. It's coming from here.
Okay.
Yeah, it's already fixed. You are not doing anything. I think you have not attended, I believe, never attended a deep learning or some other classes, because if you have attended some deep learning classes, in that case, you would not have asked me this question, because all of this parameter, I mean, like, it's not new. It's actually like a deep learning parameter, which we use for any neural network, by the way.
Good. I need to check
Yeah.
that.
Yeah. So
Other
I
questions?
think you should visit some of the deep learning lecture, maybe some of my lecture that will make you comfortable with respect to neural network.
Yeah, sure. Other things related to the different languages.
Hmm.
So different files that we need to create data files, or is
Hmm.
there any
Hmm.
possibilities I-18N kind of things we need to implement the same answer in the English we can get and
See,
that
at the
we
end
can
of the day,
convert?
yeah, at the end of the day, I need only this much, right? Maybe I have a different file, maybe I have a different data set. You are able to see my highlighted one, right?
Yeah.
I just need this one. Simple. I need in this format where I need your like a input, I need a output. That's it. Yeah, means your question, your instruction, and then its answer. Uh, I don't, my model don't need any, or my model don't even understand anything except this one. As simple as that. Yeah. So doesn't matter in which language we are trying to like train the model. Ultimately, I have to prepare my data in this format. Data is coming from maybe a text file, CSV file, two files, or maybe it's just from one single file. Uh, Basically, my model don't care about it.
So in Java, like we do the I18A, that library we use and
Hmm.
convert in any of the languages. So kind of things are there in the Python.
No, no, that is like just that is just a notation, I believe, I18A that you are talking about, right?
Yes.
It's never do a language conversion. Language conversion is something like very different. For example, if I'm saying something in English and then you have to like translate something in Hindi, so obviously like it's a complete like a translation, right, from one language to other languages. So you have to give data in that manner, basically. And if your data is bad, right, your data is bad, then it will not be able to understand.
Right.
Yeah,
Okay. Thank you.
in terms of language uh, different like a language based training. Okay, so hope all of you are enjoying it. I'll just upload this code file. Don't do much this week. I'll say maybe try to complete a previous assignment which I have given to you, which was based on N 10 assignments I have already given to you, 10 problem statements. And just try to maybe look into all of these, prepare your question for me so that you know you can come to next class and then you can ask me questions. I'll show you end to end everything. Till production means till production. We'll make it live. We'll try to integrate with a multiple system. Like I said, Telegram, maybe WhatsApp, maybe with the Yuri chat kind of a system. So fully productionized, my own custom departments. As simple as that. That will be my objective for a next week. And believe me, you all will enjoy, and you all are going to write this kind of a project directly into your resume. You say that, okay, I have worked for this department, that department, and I have like, build this model, that model, this much time, this much of data, this much of team size, everything. And this was a GPU, everything you will be able to talk about. And then I have like done this kind of inferencing, and this is how like accuracy was. Each and everything you will be able to talk about in your interview. So this is like, and this is actually a real work which every company does, by the way. Yeah, not just one company, every company does that, and they like charge their client $1 million for that one. So fine. Okay, Sumit, you have a question. Naresh, you have a question again. Okay, go ahead. Then
So
I'll
just a quick
class.
question, just in last batch on
Uh,
tuning, when you explain the mathematics, you mentioned in the Q LoRa when we reduce the matrix size,
hmm.
the new matrix size would not be a subset of the original.
No, basically it's not a subset of the original. It's like a ranking. Just it take one reference that okay, when I'm trying to create a parallel matrices, then what
Mhm.
should be the size? So it just try to take a rank reference for that one. Rank means like number of rows or columns, you can say number of rows, right? In general, as of now, if you understand the matrix multiplication and then matrix mathematics, basically. So just it takes a inspiration and then based on that it like create a parallel one, but it's not a subset of it, never. It takes a inspiration, it's try to add a delta. So basically there is something called delta w that it try
Yes.
to add over there.
Understood. And
Yeah.
so, just like in a case of like full fine tuning, if we are aware that our base model is not very much close to the what we are expecting,
Hmm.
so in that case, why we even using the base? Even we can only train a new model and based upon
Because
our own
yeah,
personal data.
because I need some model who understand at least a grammar language, maybe my Tamil, Telugu, Hindi, English, Spanish languages, because that is also
But that
important, right?
we can
Language.
do in our training data also. If I
But
train
again,
my
so if you will try to train the data with respect to languages, you need literally a very huge volume of data. Language understanding is not that easy. You need a world's conversational data for that. Getting my
so
point?
that means we are using the functionality of understanding the language, not the actual data.
Not the actual one, yeah, not the output that you are looking for with respect to your own domain. We are just looking
Mhm.
for some model. So see, for example, I'll just give you one example, right? So
Mhm.
here, there are many non-tech people in this batch. Let's suppose you are a non-tech guy, yeah,
Yeah. Okay.
and you don't understand like programming, you don't understand model anything. but
Mm-hmm.
you are able to understand whatever I'm able to teach you in a class because you understand
Mm-hmm.
at least language, English language.
Yes.
What if you are not even able to understand English language? Will you be able to understand the deep learning and this training concept which I'm teaching you?
No, there will be no communication because I don't know what you are saying.
Exactly. Same goes over here. I think you are able to get your answer, right?
Mm.
So basically, you
Okay.
were the before joining, before like enrolling into this batch, you were basically a base model, a person
Okay.
who
Okay.
understands
Nice.
just a English or like all those conversation person can understand, right? But you were not aware about a generative AI before joining this batch. Now, once you have
Got it.
joined this batch, now you are learning, right, on top of your base model. So Sumit Kumar
Mm-hmm.
was technically a base model till the date we have launched this batch, and then Sumit Kumar has started learning basically, and still like he is like a learning, but base model was required. If someone has joined my class who don't understand my language, who don't understand my English, who don't understand my punctuation and pronunciation, right? Then obviously Sumit Kumar or no one will be able to understand generative AI, right? That's the only difference, and I think that's the best example. And I believe this is an example which everyone and anyone can understand now, right,
Yeah, you
guys?
just added
Everyone
one, yeah, one, yes,
got
one
it?
more layer on top of it.
Yeah, exactly. So why do we need a good base model even, and why we should not? So if I will now, Sumit told me that okay, what if we can try to train the model from the scratch? Yeah, you can do it because transformer architecture is nothing. Just create layer by layer, and I have even done that in my classes, right?
Yes.
If you'll go and check my code base, I have already discussed about that how to train a transformer from the very scratch, right? But the problem is that let's suppose if I'll start teaching Sumit first of all English, so maybe I'll take a years of time to teach Sumit just a English language and just like the way we try to communicate, and then only I will be able to teach the generative AI specific things. Yeah, that will take a
Hmm.
lot of time. Time means what? Data. So let's suppose
Data.
I'm
Yeah.
taking 3 years of time to teach Sumit just an English. It simply means that I'm talking to Sumit, right? I'm trying to transfer the data to Sumit. Technically,
Mm.
I am like trying to send a lot of data to Sumit because Sumit will not be able to like learn English and all those like punctuation, grammar, and everything. And Sumit will not be able to communicate with me efficiently unless and until he's not having a enough like input or data. Unless and until he has not done the enough learning, right? So that will be a task in itself, and then only I will be able to like train on my generative AI. So that approach is going to be the costliest approach. That is the reason. So we take a base model.
Mm-hmm. That would be very nice explanation, sir. Very good example.
Yeah. So I think now everyone can understand this.
Thank you.
Okay. So why do we need a base model? And no one will ask me doubt on that. Okay. Go ahead. Naresh, go ahead. Your question.
Yeah, hi Sudhanshu.
Yeah.
Yeah. So let's say I have some data and I have trained my base model, right?
Hmm.
So
Hmm.
after a couple of years or 3 years later,
Hmm. Hmm. Hmm.
so I got a new data to be trained.
Hmm. Hmm. Hmm.
Now, should I take base model and train existing data and new data combined, or should I take already trained model and
Your previous model will behave as a base model this time.
okay,
Your
okay,
previous
already
model.
trained model will become my base model so that I
Base
can give
model,
my
yeah, yeah. Your train model will become a base model next time, right? Because it is already been trained on your previous set of the data, right? So
yes,
take
yes,
that as a consider that as a base model, train that, retrain that model itself. And this is
okay,
this is what we are doing when we are doing a fine tuning, right? We
yeah,
are choosing someone's else trained model.
correct,
This is technically what we are doing, right? In terms of fine tuning, we are choosing someone's else. Someone has trained the model. I'm just using it.
correct, got
So
it, got it,
next time, just use your previous model, the version one in a version two.
yeah, got it, thanks.
Yeah. Yes, we need a basic of DLNLP, not a full ML DLNLP. Yeah, I mean, like, see, base is always going to help you out. See, whatever parameter which I have written in today's class, right? Believe me, none of the parameters are new. None means literally none. If you will go through my deep learning and all this concept, right, NLP concept from my previous batch or like from my previous classes, you will be able to find out that every concept has been explained on like a grassroots level, right, in such a way, because that is a base. Doesn't matter what system you're trying to create, everything is coming from there itself, right? Even the advanced system. So I always suggest people, even nowadays I suggest people that it's fine, AI is fine, LLM is fine, GPT is fine, but at least try to spend 6 7 months of time, or maybe a good 8 9 months of time. 6 months is minimum, right? Just to build your base, because it will be with you for an entire lifetime, right? So base is important. In MLDL, I have recently started, so maybe you can join that batch as well. So you can start learning like a basic of MLDL and stats, and then maybe like you can go ahead with my deep learning lecture, or the previous lecture which I have given in full stack data science. That is also available to you, to all of you, right? Where machine stats, machine learning, deep learning, computer vision, NLP, transformer architecture, everything is available. Everything means literally everything is available, right? So that will help you out to build your base in your free time. Just do it if you want, if you wanted to become a better techie, right? So believe me, tomorrow, if your base is clear and if you're able to learn all those things, tomorrow, if new technology will come, new thing will come, you don't need me. You will be able to understand it automatically. Otherwise, you will need again and again someone like Sudhanshu Kumar to give your explanation and teach you, right? So choice is yours. As simple as that. If you don't need me tomorrow, then prepare your base first. That is already given in your dashboard. Asking algos math behind it. Yeah, company by company, obviously. They should ask. Even if I'm going to take your interview, I'll be asking a basic. I'll not be asking, because I know majority of people will get stuck there on a base side of it. Need your knowledge also. Yeah, that will be there. I'm like, I'm just telling you that form a capability in yourself. Yeah, you should not depend on anyone, even me, in future. Yeah. Okay. So thank you so much, guys. Hope all of you have enjoyed. Hope we have discussed something interesting in today's class. And even to like next class is going to be very much interesting. Saturday class, code base and everything is ready with me. I have to give you explanation. I have to host it, make it final, make all the model live, all the departments of my organization live. Integrate with multiple systems, all those innate and all those agent and Telegram, everything. And yeah, so that it will be like a real and live to all of us. So code I'll update. So once I will upload, the recording, maybe by tonight, by that time I'll upload the code as well. Yeah. So along with the recording, everything will be uploaded. So fine with that. Thank you so much. Take care, and see you again next class, guys. Saturday. Don't forget to join this Saturday class. It's going to be very important. All the classes are important, obviously, but yeah, join. Let's join Saturday's class. Thank you, everyone. Take care. Take care.